Hello, everyone. Good morning, or good afternoon, or good night. It doesn't matter where you are. Great to see you guys here. And welcome to the first Data Science Summer School organized by Hertie School Data Science Lab and Data and Methodology Center at the Scripps Cluster of Excellence. I would like to thank our funders, the Scripps and the Stifterverband, for their generous support that made this school happen. And I'm extremely happy to see you both on Zoom and on YouTube in the parallel stream session. And I would like to walk you through some organizational and technical details. If you're in the Zoom call, you're all muted and your cameras are off upon entrance. We really ask you to please do not unmute yourself and do not turn your cameras on unless you have a question. If you are in the Zoom meeting and you have a question, you can raise your hand and then whenever there's going to be a time, we will let you speak and then you will be able to unmute yourself and turn your camera on. But otherwise, you can put the questions in the chat and that might be actually faster to handle the questions for both the instructor and the teaching assistant. If you're in the YouTube session, you can leave your questions and comments in the live chat and we will try to handle them as fast as possible or just direct the questions to the instructor. I should also remind you all that the Zoom session is being recorded. And thanks in advance for following these rules. And without further ado, we shall begin with our fifth workshop in this summer school series. And today we're going to be doing Introduction to Python Programming in Python. And let me introduce you Dr. Milena Tsvetkova. She is an assistant professor of computational social science at the Department of Methodology at the London School of Economics and Political Science. In her research, she uses large-scale web-based experiments, network analysis of online data, and agent-based modeling to investigate fundamental social phenomena such as cooperation, social contagion, segregation, and inequality. And Milena, the floor is yours, and you can share your screen now. Thanks.
Okay, hi everyone. Nice to see so many of you here from all over Europe, I assume. So let me start sharing my screen. Okay. There we go. So I hope everyone can see that. So this is an introductory course to programming using Python. So I just wanted to give you an overview of what we're going to, well, who we are first, and then what we're going to do today. So first, so I'm Milena, as Olga mentioned, and I wanted to introduce to you Yuan Mohi, who is the teaching assistant. And Yuan will be able to answer some of your questions in writing, and he will also bring some of your questions to my attention if we feel that everyone should hear the answer. So the schedule today, so we'll have 4 hours, 2 hours with a short break, and then 2 hours afterwards. And we will start with introducing the basics of the Python programming language. I will start with control flow. So some of you might already have knowledge of other programming languages. Here we will be really focusing on the kind of the most fundamental aspects of all programming languages, but using Python as a particular case. And so we look at conditional statements, iteration, and at functions. And at the beginning, I'll very briefly mention about object-oriented programming and the use of classes. Now, some of this might be a bit theoretical, but there would be one extended example that I'll be using. And the example is looking at the inauguration speeches of the last two presidents, well, the current and the last president of the United States. So it's just a very kind of simple example where we would use basic, what we learn in more theoretically to apply it to an actual data science task for the social sciences. Okay, so let me start. So again, feel free to use the chat for questions. I'm not very good at multitasking, so I won't be able to answer those while I'm speaking, obviously, but hopefully we will have some time to address those at here and there. Maybe I'll pause strategically at some point. Okay, so let me now talk about, again, you here, so obviously you have some motivation to learn computer programming, but I wanted to make sure that we're all on the same page of why do social scientists need computer programming. So we live in a world of a lot of digital data, a lot of digital traces online that people leave because they shop online, they communicate online, they meet friends, make new friends online, they work online, and so on. So computer programming helps us collect this kind of data. So we can do that either using APIs, so application programming interfaces, or crawling websites. Also, in kind of different realm of the social sciences, you can now design and implement and develop program experiments online with a large number of people. So they could be kind of field interventions, so they could be completely lab experiments in online virtual labs. And then, of course, also computer programming helps us with numerical simulation and agent-based models, for example. So we can create artificial worlds and study those in our machines, basically. So all of these require some kind of knowledge of computer programming. Now, once we have our data, we also need to analyze it. We need to manage it. We have to often, if we have different sources of data, we need to combine them together. We need to somehow make it uniform. So computer programming is necessary for large amounts of data, stuff you cannot do in Stato or in SPSS or in more traditional statistical software, for example. But also it's necessary often for what is known as non-rectangular net data. So networks are a bit, right, because you can represent a network as a matrix. So some people think it is a rectangular data, but obviously there are ways to analyze it that doesn't necessarily help you with that. But text, for example, is a good example of non-rectangular data. So the data that you cannot just put in a CSV spreadsheet and use kind of typical traditional software. And so you need some computer programming to understand how to do text analysis and to actually do it. Now, on a different level, what computer programming allows social scientists is to work independently. So we don't need to rely on computer programmers, engineers to come up with the solution to our own problems, right? But on the other hand, also, it actually helps us to work with people outside of the social sciences. So it helps us work with natural scientists, with engineers, where you can think of, computer programming as the lingua franca, right? A common language where we can communicate maths pretty much, right? Like where we can, even without knowing the terminology in different disciplines, we have something, a way of thinking together, a universal way of thinking and doing things. And finally, I think, and this is very important and becoming more and more so important, is that computer programming help us generate and share reproducible workflows, right? So computer programming, instead of clicking through like some kind of software interface, computer programming has this record of the actions you need to take to produce the results that you have in your report, or in your paper, on your dissertation, and so on, right? And so this is important to kind of to increase trust in science and to also learn from each other in a sense and build upon each other's work. Okay, so hopefully, as I mentioned, you're already here, so you're curious about this, but hopefully now there is enough motivation for all of us to go through this. Okay, so now, before we start, I wanted to, so we are going to learn a programming language called Python, but I wanted to make a clear distinction between markup and programming languages. So sometimes people think that these are the same thing. So they say like, oh yeah, I have programming experience. I have done some HTML programming. HTML is not really a programming language. So this is known as a kind of a scripting language or a markup language. So the difference is that, so we, on the one hand, we have markup languages such as LaTeX, for example, or TeX, HTML, Markdown. Actually, these files using Markdown, so we'll go a bit more in detail when we look at Google Colab. But on the other hand, we have programming languages such as C, Java, JavaScript, R, or Python. And so the difference is that while markup languages, the goal is to structure and present data, programming languages, they actually transform, they manipulate the data, and they can generate new data, right? So they're not just kind of representing data, they actually could be generating and manipulating and changing the data. And so markup languages are usually, you need a software to render it, right? So your browser, for example, to render HTML, or so the program to read LaTeX, while programming languages speak in some way directly. I mean, often it's indirectly, but they do speak to the hardware more directly than a markup language does. And then we can see, I have an example here that also the structure is very different. So markup language would have these inline tags that would show how to render a particular part of the text, while a programming language has what is known as primitive constructs. So there would be things such as characters and numbers and operators. So here the equal sign or the plus sign, they're operators. They're also programming languages characterized by syntax, meaning that there is a certain grammatically correct way to put statements that the computer would consider at all. And then also there is the important part that you can put certain statements, but that look grammatically correct, but the computer doesn't know what to do with them. So for example, often a programming language wouldn't know what to do if you're adding a number with a character, for example, right? Sometimes it will give you an error. And finally, also, what's important here is the programming language. What you do is that you give kind of structured instructions to a computer to execute certain tasks. And so the semantics determine what you're trying to tell the computer to do. And in comparison to natural language, programming languages, semantics are very straightforward, right? There are no metaphors, there's no irony, there's no sarcasm, there's only one meaning, right? Otherwise, computers will be very unpredictable. But of course, the issue for us programmers is that there is often miscommunication in the meaning we think we're giving the computer is not exactly the one that the computer understands. And that's where kind of the most serious bugs occur, where you don't even realize that the computer is interpreting this incorrectly. But we'll go over these a bit in more detail. Okay, so as a matter of fact, I differentiate between markup languages and programming languages, but as I mentioned, this document, so the Google Colab notebook, has both. So if I click on this, you can see that this is a markup language. It's called Markdown, and it uses certain kind of tags to determine how to. So for example, this says it's bold. This one says it's going to be a second level heading, and so on, right? So this is already, these documents use both, okay? But we will focus here on Python, not go into too much detail about markup. Right, okay, so why Python? So a lot of social scientists are using R, and there is almost a bit of a kind of a rivalry between users of R and Python. I am obviously biased. I'm teaching Python here, so I hope that I'll convince you that there is a reason to learn that, even if you know R already. But Python's similar to R, actually. It's open source. It's free and well documented. There is a large community on Python that has kind of created the language and have addressed a lot of questions and keep on updating it and addressing a lot of questions. It has very simple and concise syntax. It's a lot of people compare it to almost natural language. You can almost read it like natural language. And it has a lot of useful libraries. Now I wanted to show you here, I hope you can see that. So I will stop the annoying music. But this is a video of the most popular programming languages on Stack Overflow. So if some of you are not familiar with Stack Overflow, you will be, believe me, if you start programming. So this is a website where programmers ask questions and others programmers answer them. And these days, that's how most of us program. Basically, if you have a problem, you just ask a question. So here you can see that. So we have over time, the percentages of questions that were asked about a particular language. So now in 2014, Python is starting to grow up, but it still hasn't caught up. Let me see if I can speed this up. Okay, well, we'll just wait through it. But what I'm trying to convince you is that Python is growing a lot in popularity. And these days, a lot of employers expect it. So it's something that would really increase your kind of employment capabilities. And it's also becoming more and more common okay, let's make sure. All right. It's coming more and more common in academia too. So we keep on hiring actually people at LSE just because they know Python, and that gives them an edge. So hopefully at the end of this, you'll be convinced to continue working with Python. Okay, so now I believe that probably some of you already have worked with Google Colab if you've visited the other 4 courses in this program. But just to make sure that we are not leaving anyone behind. So these slides, I mean, I'm showing them to you in a slide format, but this is a document which is known as a kind of a JSON Jupyter notebook document that, as you saw, is a combination of Markdown, so of text, formatted text, but then also, as we'll see later, code actually that we can execute. And you can open this on Google Colab. So if you go to this link with the Python workshop, I'll also posted it in the notes. You can find the Google Colab link there. And so let me see, I can hopefully do that right now. So if you click on this link, it might take a bit. So what happens is that Google now creates a kind of a virtual instance of a computer where you could open this file and work without having to install anything on your computer. So now let me see if you do this. All right. Okay, so you may have to sign in. So you need a Google account. So I will actually use another account because if I use this one, then that's the owner of this account. So I will log to my alma mater's account, which for some reason still works. So I went to Cornell. Okay, let's hope it works. Oh boy. Right. Okay. So once you log in, you would be able to open this file with Google Collaborator. So if you click on this, if you don't have it, you may have to install. So I think there was an option of saying install other apps, and then you have to look for Collab and install it. It happens pretty fast. And so now you're going to, you'll be able to open this document. And that's how it looks like. You also have to notice that some of these cells are hidden. So you just have to click on them and it will unwrap them, right? You can also look at the contents to just get an idea. Sorry, what was the contents? Here, yes, table of contents. Just get an idea of where we are and where we're going. And more importantly, because this is a document that I'm the owner of, and there are a lot of you. So if you want to have your own copy, and I highly recommend it because you can take notes that way, you can make changes, you can run your own code. So I would recommend that you click on these changes will not be saved and save a copy in Drive. So this way it will create a copy in your own Drive. And so you can work on that copy itself and you can save changes there. Okay, and just to again iterate about Markdown. So if you double click on one of these cells, so this is a Markdown cell, and you can see how it looks like. So this is the structure. This is how it's previewed. And if you, let's see, we can go to a code cell a bit later. All right here. So this is the code cell, so it looks a bit different. You can run this code. So one way is you can press this play button, or you can do control or command, depending on your computer, on your operating system. So on a Mac, it's a control enter or command enter, maybe, or whatever is the equivalent in a Windows system. So, and then you can just run the code. All right, and then there are also ways you can add new code cells, you can add new text cells if you want to write notes. You can also, of course, edit these other ones too. And just to warn you that if there is a problem, let's see. Yeah, I think we don't have to worry about it. But if there's a problem, you may have to interrupt execution if that happens. So if you have written something and it just keeps on going and the computer is crashing, that's sometimes you may have to, you have written a infinite loop that might crash your computer. But hopefully we don't have to do this right now. Okay, so some of you might be familiar with this. Hopefully others know how to do it. If you have questions, please write them down, and hopefully Olga, Hui, and Joanmo will be able to lead you through how to do this.
Milena, before we get into the programming, there is an interesting question from YouTube, which is, can you say something about the advantages and the disadvantages of R versus Python? Why would one choose one over the other?
Yeah, okay, that's a great question. So so Python is a language. So okay, so R is a statistician's language. So it's a language that is more, it kind of started from statistics and is more popular among social scientists for that reason, right? It reached through to social science via statisticians. Python is a more universal language that, and in R kind of is focused on data analysis, right? Python is more general language that is, computer programmers language that's widely used in the natural sciences, particularly, right? So physicists use them, biologists. So there is kind of historical differences in that. And also in terms of kind of libraries, that's also reflected in that. So for example, Python has a lot of kind of scientific computing libraries about simulations, more general, right? But also has a web development platforms, and R is really more focused on analysis. So for so for example, R is actually better for some kind of network analysis methods, while Python might be a bit more developed in more computer sciences areas such as machine learning, for example. So that's kind of the difference. And I think that if you know Python, you will fit much better in a general office where there would be computer programmers or software engineers next to data analysts. So R might be sufficient if you, for example, work for a government agency that is mainly of social scientists doing research, right? So that might be good. But I think knowing Python would really open up your possibilities for the kind of the core industry, right? Like so software development, online services, and so on, right? So to me, this is kind of more practical terms. That's the differences, of course, right? In terms of the core, there are kind of different data structures, right? So there are lots of details on how the languages differ, but I think we don't have to discuss this at this point. Okay, great. So let's continue. So I hope you all managed to open this file. You can also feel free to kind of follow maybe both the slides and the file if you want. This is more or less the same content, but I'm in the right form. Okay, so we already looked at that. All right, so let's start. Let's start with Python. So as I mentioned, it will start a bit slowly just to make sure, because these are kind of the fundamentals. And these exist in all programming languages. They're very specific. So if you know R, you already start noticing differences between R and Python. But you just want to make sure that you kind of understand the basics. And then more interestingly, we're going to come back around at the very end when we start looking at classes. Because everything in Python is based on the class system, so it's an object, but we'll talk about a bit later. All right, so let's start with the basics. So computer programs manipulate data in the form of objects. Okay, so data in computers are sometimes as objects, and these objects could be of different type. So we can have kind of smallest units you can think of, so indivisible data type. So you can think of an integer, right? Like, so it's if you not think about maths, but or like a character, right? Like, so this is kind of, you cannot break it down in smaller parts. But then you can also get data types that are, for example, a data frame or like a table, right? Or a list of items. So this is a different data type that is consisting of these small indivisible units, but this particular data item could be broken into multiple parts. And more importantly, so the whole point is that we have our data, it comes in some kind of object, and then we can do things with these objects or with the data. So we can, for example, call this object names. So we can not insult them, obviously, but so you can name it. So that's how we do when we assign a variable. So we can say, I'm going to call this data object, I'm going to call it, my data. And then anytime I refer to it, I don't have to, type in the data. I can just refer to it with the name I have given it. You can also combine different data objects in expressions. So for example, you can add 2 integers, right? You can also call methods on these objects. So again, we'll get into more detail, but it is like you can do things to these things, and you can also pass them to functions. So again, both methods and functions, what they do is that they transform this data, do something with it, and then they would either give you the transformed data or they would return some new value. So, okay, so this is a bit overwhelming, but the data types, these are the basic data types in Python. And so you can see that we have these kind of scalar or basic units. So we have an integer, a float, which is a floating point number. We have a Boolean, which is true or false. We have the none value, so nothing. So these are the kind of the basic ones, right? And they're immutable in the sense that they don't change. Basically, once we define it, we can only overwrite it, but we cannot transform it in another way. We cannot add to it without defining a new object. But then we have these composite data types. So we have a string, which is basically can have separate characters. We have tuple, list, set, and dictionary. We'll go over this in more detail, but also what's to mention here is that some of these cannot be changed. Some others can be modified, as the object could kind of grow and change and be redefined. And some of them are ordered and others are unordered. So ordered means that I can identify which is the first item, the second item, third. So for example, a string, right? Like so text, right? You know where each character stands. But some of them are collections that don't have a particular order. So we'll start with the basics. So, okay, so we have integer and float. So integer is simply in Python, right? So this is an integer. So something maybe right away to mention is that what I did now is I typed a number and I entered Control Enter in my computer, or you can also play the play on your the play button on your Google Colab. And when I do that, it gets evaluated. Okay, so this is the, what's in the input, and this is the output, 34, right? So in this case, all I'm doing is I'm just evaluating, and tells me that that's what it is. Another way I can get this to be represented is if I use print. So print is a function you can use. So it's good to look at this right away. So because this is a very useful function. So in this case, what happens is that I have a string representation here. So you can see that it's no longer the output, the evaluation, but it's just, it prints it, right? It renders it as a string. And the other thing I can also do very simply now is that I can call this a name, right? So I'm going to define a variable called a equals 34. And now I can evaluate the variable a. So it gives me, again, 34, or I can print it. And more importantly, of course, I can, define another variable. So now I'm going to do a float. And regardless of where I am, right, I can still refer to what has been already saved in memory. Okay, so this is an integer, this is a float. I can make this a string. So string you can do with quotation marks, could be single quotes or double quotes. So, okay, another way to do this is like that, right? And then more interestingly also is, of course, the true or false. So these are the Booleans. So whether something is true, so I can evaluate this and it will tell me it's true or false, right? So that's another, so mind also so this language is case sensitive. So note how this is written. You can also see that it is the syntax is emphasized. So if Python recognizes that this is a meaningful object, it will change the color. So if I misspell this, you can see that now it's no longer recognized as a particular type. So that's also kind of can give you some clues that you're typing something incorrectly. And then there is also the none type, right? So we have none, it's, if you just evaluate it, it's nothing happens, right? Because none means just nothing, right? But if I print it, it has a string representation, so it will type me none, but the evaluation of none is nothing. Okay, so these are the very basic kind of indivisible units in Python. Now, we also have units that are, so the object types that are composed of these indivisible or composed of each other. So in Python, a string, as I mentioned already, is actually a non-scalar data type because it doesn't matter whether it's only one character or multiple. You know, in principle, you can have multiple. So it's composed of multiple characters, right? We have a list, and the way to define a list is with square brackets. So I can have a list like that. And so each item is separated with a comma. We can have a dictionary, and dictionary is a kind of a collection of keys and values. So in this case, I have key and it might have a value, right? So you can have any kind of, so for example, right, my keys could be letters, and for each key, there is a value associated with it. And so this is how we can define it simply. So we have the curly brackets, we have the key, then colon, and then the value itself. We also have a tuple. So tuple are very similar to lists, but you use the regular brackets. Okay. And the difference between a list and a tuple is that a tuple, once it's defined, you cannot change it. So you can overwrite it, but you cannot add items, for example. For a list, you can, and we'll see how to do that. And then there is a set. So a set, you use curly brackets, but now you are having different items added. And so what a set does is that it will evaluate this to the unique item. So it's a collection of unique items. So for example, if I evaluate set right now, it will give me only the unique items. And something to note about set is that it is unordered. So in this case, actually, so it's a bit hard. So I gave you some example of where the you might notice that the order changes. Let me see if this happens. No, it doesn't happen this way. Let me see if I print it. I cannot always get it right, but like it's basically unpredictable when the order will change of how it's represented. So you should just assume that set is a collection, so it's not ordered, right? So these are different types of data, right? So you can have all kinds of elements. You can actually have, in some cases, you can have, you know, tuple of tuples, for example. That's one option. So you can nest them with each other, but there are different ways in which you can combine data. And of course, which one you choose depends on what you're trying to do with it, right? So if you, for example, starting a collection with items and you know you're going to keep on changing this collection, so you might have to remove some of the items. You also, for you, the order is important. Then you should use a list, right? Because it allows you to change this list, and also you can identify where items are by order. If you need only the unique items, a set is best. You know, if you need to be able to easily refer to an item without knowing when you have added it, but you need to kind of, you have an easy key value you can use, so then a dictionary is better, right? So hopefully once we give you the example, you will kind of start developing some intuition about this. Right, so we have, you know, different kinds of data, and we can do different things with it. So we can have, we can use operators to combine the objects into expressions. So very simply, we can do arithmetic with the objects, right? So more simply, we can do, you know, for example, we can add two integers, we can evaluate them. interestingly, also we can also add or concatenate two strings. And now you can see that what this does, because these are strings, to us it looks like a number, but because I have defined to Python that it's a string and with the quotation marks, this is now using the operator changes meaning, and so this now concatenates these numbers, right? Another thing I forgot to mention is, and you hopefully already noticed, is that we can add comments in the text, and so feel free to comment through this out, and to do that you have to use the pound sign, right? So what happens is this is a comment. It doesn't get evaluated. These are notes that you can give to yourself or to other programmers about what the actual code is doing. Okay, so this is simple. You can do the same with actually with multiplication, that it has different meanings. So now what we do is that we repeat the string, that is 2 in this case. We can do it also with letters 3 times, and then we append 2 at the end. Now we also have Booleans. So if you haven't done any programming, this might be a bit confusing, but Boolean is, it's right, has 2 values, true or false, and you can do operations with it. So you can use and or not. So true, for example, evaluates to true, but if you say not true, it will evaluate to false, right? You can say true and true, so that will evaluate to true because both of them are true. But if you have one of them false, it will evaluate to false because at least one is not true, right? And then if you have or, it will give you if either of them is true, which in this case is true, right? If both of them are false, it will be false. So again, for some of you, this might be familiar. For others, it might be quite confusing, but it takes a bit of kind of getting used to. They're quite useful Booleans. Now, all right, so this is also something else. So we have these comparison operators. So we can test whether something is equal, not equal, less than, so that's less than, or it can be greater or greater than, and so on, right? Now, what is important is that I already showed you assignment of where we can use one equal sign and assign a variable name. So now we have a variable called a that it has been assigned the value of 2, an integer of 2, right? Equal to 2. But this is assignment, but then I can test now whether a equals 2. So this is a test. So this, it gets evaluated. So this is assignment. Basically, it saves this object in memory, calls it a, and I can keep on referring to it. And what this does is it gets evaluated. It's an expression that gets evaluated, and this will give me now true or false, right? So in this case, this will be true because a, I have just defined it to be 2, and that is true. If I test whether it's 4, it will be false, right? Because I just said it's going to be 2. Right? So this is, so that's kind of, we have to be careful about this. This is assignment. I just call this object a, and this is a test of whether a equals 4. So it's a comparison operator that gets evaluated. You can also, in Python, you can use this kind of special ways of like shortcuts of where I can use plus equals 4. So what this does is that this is equivalent to a equals a plus 4, right? So it's just a shortcut instead of mentioning a here. So what this will evaluate to is 6, right? Because I have defined a equals 2, and using the shortcut, I'm saying now increment a by 4. And then there is the membership operator. So if you have a list, or some kind of collection, right? So let's use a list here. I can test whether 3 is in B, and this will say that's true. If I test if 5 is in B, this will be false, right? So again, this is an expression, and you can use operators or kind of these keywords to start kind of evaluate different types of data, right? So you can combine data, you can start adding things, you can test already a lot of things, and we can search, for example, for items with the in operator. Okay, so all relatively kind of straightforward if you have done this. Otherwise, a lot of it is, makes sense that you have data and you can do things with it. Now, let's move on to different types of non-scalar objects. Remember, these are objects that have internal structure. And here, what we're differentiating between is unordered types versus sequences. So the unordered types are the set and the dictionary. So set was a unique collection, right? So it's a collection of unique items, and dictionary is a key value pairs. And the idea with the dictionaries is that unlike physical, well, actually it is unlike a physical dictionary where actually words are ordered, but in this case in the computer dictionary it's not ordered, right? Like it's you can search things straight away by the key that they have. But items such as objects such as strings, lists, and tuples, they're ordered, right? So everything has an order. So right, so here we have the set. So actually, I think this might work. So I have defined a set, and if I am to print the set, you can see that the representation of this set does not correspond to the order we entered it in. And this is, again, just to kind of to show you, give you an idea that you should approach these collections as unordered, and you can test whether something is in there, but you cannot say, give me the second item, for example, because you don't know what the second item is, especially if it has repetitive items, right? Right, and dictionary is another unordered collection. And as I mentioned already, is that dictionaries, we can index them by the keys. So here I have a dictionary with the characters from a TV show called The Big Bang Theory that some of you might have seen. And what I can do is that I can look up elements from this dictionary. So if I know, sorry, I misspelled the name. So if I know the person I'm looking for, so let's say Penny in this case, it will give me the value, right? So this is how you do the lookup. You use the square brackets and you put in the key. So I have my dictionary and I can look up the item that stands behind key Penny, and it will give me the answer. Right, so you can do this very quick lookup in a dictionary without knowing when exactly you enter the item, for example, where it is. You just know the key. Now, so these were the unordered, right? So you can test whether something is in there. We can look it up in a dictionary. You cannot do that in a set, but you can test whether it's in there. Now, with the ordered scalar objects, non-scalar objects, we can now we can identify the position of a place and get of an item, and we can get that item based on its position. Something to remember in Python, and a lot of programming languages, R is an exception, is that indexing starts from 0. So you have your list. Let's just do that. Okay, so we have a list. And what is important in Python is the position, the counting of the position starts from 0. So I have item 1, but the actual position is 0. So honestly, to make this easier, maybe I will name them letters so that there isn't confusion about what is a position and what is a. Okay, so I can index. So what I'm asking now is give me the item, the element that's in position 0. And what this will give me is A. If I say, give me the element in position 1, it will give me B. So remember, what we do here is that each element has a position, but we start from 0, 1, 2, 3. As I mentioned in R, this is different. We start counting from 1. But this is not unusual for programming languages to start counting from 0. Now, what happens if I say, give me an item position 2? It will give me the last one. But if I say position 3, sorry, I have say position 4, what it tells me, I get an error saying that the list index is out of range, right? Because my item only has 4 elements. So that will be position 0, 1, 2, 3. And position 4 would be afterwards, and it doesn't exist. So I get an error. It tells me, okay, this doesn't exist, right? So this is simple indexing. You can also slice, so you can get parts of this. So you can say, give me the second two so this will be the second and the third, but not the fourth, right? So from position 1 to position 3, but without position 3. So this will be B and C. So again, so not the 0, position 1, then position 2, up to 3, but not including, right? So that's why it returns this. So again, this takes a bit of time to get used to, but once you kind of shift your thinking of starting from 0 and then realize that the end is not included, then it gets kind of more natural, right? So often you have to shift your thinking about this. And then there are also kind of a more extended slicing you can do of where you have the steps. So something else to note here is that I can skip some of these indices. So if I do the column, and then basically what this tells me is start from the beginning and then give me 0, 1, 2, up to 3, but without 3, right? So it will be A, B, C, right? And you can do the opposite too. So now it says start from position 2. So that would be 0, 1, 2. So that will be starting from C. And then give me from C until the end. And then, of course, if you don't include any of the positions and you just use a colon, what this does, it starts from the beginning and to the end, and basically it gives you a copy of the list, right? It gives you every single element. So these are just different ways to say, okay, I need a first element of this list. I know this is the list, so everything is ordered. So I can rely on this, and that's how I can find elements in this list. And you can do the same with tuples, for example, right? So, or strings, right? So if you have a string, I can do the same. So I can say, give me the first element. So that will be S. Give me the fourth element. That will be an empty space, because that's where. So I actually shouldn't say the fourth element. Give me element of index 4, right? So that will be 0, 1, 2, 3, 4, right? So that's the fifth element. So again, takes a bit of time to get used to, but we count from 0 and we can identify the position of an element. And this could come in handy in a lot of situations. Hopefully I'll show you more specifically how to do that. So now I mentioned already that we're going to use an example project. So I kind of introduced you some of the very basic types, data types that we have in Python, starting from the integers, floats, strings, lists, tuples, and so on. And so now let's see very simply, just to kind of bring in the data already and start thinking about it. So what we'll do now is that I went to this website, Miller Center. I'm not a political scientist, by the way, so I'm not sure how reliable this is. I just found very quickly that I can find the text of all American presidents' inaugural, actually all speeches, not just inaugural, but I focused on the inaugural speeches. And I went to this website and I downloaded the text in these two files. So just copy and paste it. You can, of course, once you know how to program, you can do this more in more advanced way. And what I'm trying to do now is to use this example to show you how, even knowing these very basic, simple things we learned, that you can already do some good text analysis, actually. Of course, in real life, we will be, once you get more comfortable with programming, you will be using the dedicated libraries that have already implemented this of text analysis, but it's often important to understand what exactly is happening when you're just calling someone else's function. So, so I have these two files, actually put them on my website so that you can access them. And so for now, you can, we don't need to focus so much on this code, but what this code does is that it imports a library that allows us to handle URLs and to make calls to an URL. As I mentioned, I saved these texts files on my website so that you can access them from Google Colab. They also are on the GitHub. So if you want to use kind of local, and you know how to do this using Jupyter notebooks installed on your computer, cloning the repository and so on, hopefully by the end of maybe this summer school, you'll be able to do all of this, but the files are also there. But what we do here is that we define an empty variable. It's a string, right? We call it text. Currently, it's just an empty string, right? I have the 2 quotation marks. There's nothing in between. And then we have our file. And so I will open the file using this library, start reading it. And for each line, I would read the line, decode it to make sure that it's read right into UTF-8. And then I add it to this text variable. And so now I can see what this looks like. So if I evaluate this, you can see that I have quite a large output. So this is the speech. So this is Trump's inaugural speech, and you can read it, right? So Chief Justice Roberts, President Carter, President Clinton, and so on. You can also note already is that we have these characters, special characters. So this is a new line character. And that's because the way the text was entered is that each of this is a new line. Actually, it even had like empty lines between every statement. And so I have 2 double new lines here. But this gives us all of it. Of course, in cases like that, this is quite a long speech and just reading all of it might not be so useful. So we can already use slicing to get just part of it, right? Instead of putting all of this, you can see it doesn't even fit here. I mean, I may have to exit to look at it, but I can just show you, for example, the first 500 characters of this, right? So I'm starting from, so this is a text, I know it's a string variable, it is ordered. So I can start from the beginning up to the position 500. So this will give me the first 500 characters. And so this is how it looks like now, right? So I can do a bit more if this is not enough to just kind of, it still now fits, but it just gives me a glimpse of at the beginning, right? So just using simple string variable, understanding how that they are ordered and that we can index them and slice them, we can now already select part of data for our purposes, which in this case, we just want to see how the data looks like. Okay, so we'll keep on coming back to this example, right? I just wanted to right away show you that this all may seem very kind of minor and small, but it is actually already useful. All right.
Sorry, Milena.
Yes,
it might be useful to also show people the how to index from reverse order with the minus.
Sure.
sign.
Yeah. So that's an option. So okay, let's see. Well, that will be all right. Let me do another. Okay, let's do. So we have some string. So you can also index from the back. So for example, if you just use -1, what this will give you is that will give you the last character, right? So if it's so this is also very tricky, right? Because if it's at the beginning, if you say 0, if you want the first character, you just have to say 0. But if you want the last one, you say -1. And so what this does is it starts from the back and gives you the one that's the last one, right? And so then, of course, there are ways in which you can say, give me, let's see. So actually, this gets a bit confusing. So what this will do is that it will start. Yeah, so this starts from, gives you the whole string, right? So from the beginning to the end, but it does it in steps of -1. So it basically reverses the string, right? So that's another way to do it. You can also, for example, let's see, if we do start from -3 and go to the end, it will give you, right? Like, so it starts from the third from the last, so I and G, right? So you can use a minus to start from the back forward or backwards, right? So it depends on whether you're having the steps or the, so yeah, so there are all these kind of different, extra things. Unfortunately, we have quite a lot to cover today, so I'm not going over all of these. And as you can notice also, if you have the file open, that I am, I'm not even showing all the examples that I have in the file because to save some time, but you have more examples in the file itself and a bit more explanation in some of these cases. So, and I also have resources which I'll direct you for later, where you can continue learning about Python. Okay.
Milena, another question that may be of interest of many people is from YouTube is I'm struggling a bit to say what would be the advantage of the tuple over a list. Why would I be interested in tuple? Yes, tuple, yeah.
Yes, no, so that's a very good question. It's a bit advanced question actually, because, right. Okay, so tuple is more efficient than a list because tuple is not mutable. So basically once you define it, you cannot change it. And Python knows that. And so the way it allocates memory is that it knows how long it will be, it knows which items has. And so it doesn't need to allocate more memory in case you want to change it, right? So this is the very short answer. The tuples are more efficient. So for example, we have coordinates of things that might not change. Tuples are great, right? But if you have like a list that you keep on populating by reading through data, like we do here, for example, for text, it's a string in this case, but you can also have a list, then you shouldn't use tuple, because what you do is then you keep on overriding it, and that obviously there is one overhead on that. There is another answer which is more advanced, so this I might confuse you more, but the short answer is that tuple can be a key in a dictionary, but a list cannot be. And the reason is that because list is a mutable object, right? This means that then using it as a key, it just becomes meaningless, because if your key can keep on changing, then there's no way you can find anything, right? So this is also another reason why there is a value in having an object that looks very similar, but a tuple is fixed. Python knows this. It allocates the right amount of memory, and then you can use it for things such as a key in a dictionary, where it knows the value and it knows it won't change, right? Which for a list is not the case. So that's kind of the answer to this. So they're both useful, right? So once you kind of advanced, lists are kind of the workhorse for Python. So they are kind of the most efficient. So Python is optimized to do, and lists optimized for indexing, and they're kind of the most efficient structures in Python. But again, it depends on your applications and how you need to, how you kind of bringing in the data, and then also how you're accessing it, right? So if obviously list one won't work for things that are not naturally ordered or don't come in certain order, right? So then a dictionary might be faster, where especially you don't know how to look for things, and if it doesn't change so much. Yep. Okay. Any more questions? All right. Let's go. Yep.
Sorry. Another question is, if indexing starts from 0, does that represent a problem when doing matrix algebra?
No. It shouldn't. There's no reason for that, right? So just, I mean, everything is shifted, right? But there is no problem. So yeah, so for matrix algebra, there is a library called NumPy that is specifically kind of built for mathematical, more advanced mathematical operations and arrays, and it's a Python library, so it is basically using, and actually I think it's implemented in C, which C also starts from 0. So yeah, so it's actually starting from 0 is a very, very common. It just shift everything, right? And there is it's also, there are parallels in real life, right? It's when you think about how we count birthdays, right? Like your first year is 0 in a sense, right? So it's so we, in real life we do count from 0 to in some cases. So yeah. Okay. All right, so let's move on to, we're talking about things such as, so we had our different kinds of objects. We talked about how to combine them in expressions that can be evaluated using operators, such as, arithmetical operators or Boolean operators. And we also looked at ways in which we can find elements in this object. So we can index, for example, right? So either with using a key in a dictionary, or we can use the position, the index, in an ordered sequence, such as a string, tuple, or a list. Now we can do more things with objects. So one thing is that we can use a function, and we can pass the object as an argument to that function, and we can transform this object. So one example is that all of these types that I showed, they have a name, and we can actually convert from one type to another. So we can, for example, make an integer into a float. So now if I evaluate this, you can see that I have an added. So basically Python interprets this as an integer. I can also make the same, let's see if this is going to work. Okay, the same with a string. So now I have a string that to us, it looks like a number. And if I say make it into a float, Python will be able to do that, right? So I can do the same with like an integer, right? So we can use this, the name of a type, to transform into from one type to another. Something else, so I can do the same with a Boolean. So let's see what has happened. So any Boolean that is not 0 is actually true. Sorry, any integer that is not 0 in Boolean is true. If it's 0, that should be, oh no, false. Okay, so let's see if I do -1. So for this stuff, you have to, right? You have to some programmer decided this is how Python is going to interpret this. So you have to know how this behaves. But the idea is that often we can go from one type to another. And I think, for example, if it's a string, any non-empty string is true. The empty string is false. And more usefully for us, more often, is that you can use this length function of where anytime we have some kind of collection or a sequence, it will give us the length of this item, right? So here we have a string. It gave me how long it is. I can have a set. So what this gives me is the length of the set. Now remember that the set is unique elements. So in this case, I entered more than they are unique. So the unique ones are only 4. And so it tells me that the length of the set is 4. And so you can apply this to any non-scalar object that has some kind of length. It consists of parts, right? So we'll use this in a bit in the example. So that's why I'm going over this. Now, this was a function where you have things such as length, and then in brackets, you give it the the argument. So you give the object as an argument. We also have another way to work with objects, which is called the method. So we have a method, an object, and then we attach a method to it. So we use this dot operator, and then we call this method to it, and it can do different, again, transform this in some way. So, for example, I can make this in string 1, I can make it into uppercase. And so I'm called the upper method on this particular string. And what it does, it goes over each character and it transforms into uppercase. Now, there are a lot of, particularly regarding strings, but also regarding all of these data types, there are a lot of things you can do with them, right? So a lot of methods. So here I have listed just some of them. If you click on this link, actually, let me do that now. You can, it just leads you to kind of one of the Python documentation, and it will give you all of the options here of what you can do with a string. So, as a beginning programmer, you won't know, I mean, even I don't know all of these by heart. So you will find your favorite ones, and you learn those, and then you should have some awareness of what other things might be possible. And if not, you can always look it up on Stack Overflow or Google, and somebody will tell you that, oh, there is already a method for that, you can use it. So here's just a sample of what you can do with strings in particular. Again, there's something similar for lists, for tuples, for dictionaries, and so on. But for example, you can transform a string into uppercase. You can transform it into lowercase. You can just do it like a sentence case. So just capitalize the first word. You can find a substring. You can replace one substring with another. So this is your data, and you say replace this substring with this one, right? So it's also, you have to be careful of what you put in, what you call on. So which is the object that you want to manipulate, and then what you want to replace with what. You can remove white space characters or specific characters here. So that's with a strip. You can split a string into a list. So if you have a string, every character, well, actually, in this case, it depends on what you're splitting, right? So if you're splitting on white space, for example, it will give you all the words in a sense, if your text is formatted properly. So you can split every word separately, and we'll see how to do that. And then the opposite is that you can also join. So you can use your string as a connector and then feed it a list of elements. And then each element from this list would be joined to the next one with your connector, with the string that you have. So here is an example. So actually some examples. So what I've done is, okay, I have a string, and I'm gonna make it uppercase. Here I have another string, and what I'm asking is to capitalize it and add a full stop at the end, right? So here I'm mixing a method with, this is the operation. So we have an operator, so this becomes an expression, right? So you can start kind of combining these operations together, right? You can put all of this into a function if you want, right? So you can kind of string different methods and operations and so on, as long as the computer understands what to do. And then this one, what I'm doing is I'm finding I, and what find does is it will find the index of the first instance. So that will be this I here, right? So it finds the first one and it returns 0. So if I evaluate this, so this is exactly, so I'm printing here all of these separately. So this becomes uppercase. This one I capitalized and added a full stop. So it looks more like a sentence now. And here I got the index of the first I in this sentence, which happens to be index 1 or the second position. Okay, so now we can also, very briefly, maybe, let me see how we're doing on time. Okay, so so you can do a lot of other, right, like elements, a lot of other, we can call all of these on this string. So for example, you can see that this particular string has these trailing characters. So we have the new line, which we saw in our data set with the speeches. We also have this problem that we have these new lines. And here we have a trailing white space. So we can use the strip. Let's see if actually yes, this will evaluate, right? So we can use the strip method, and by default, if you don't specify anything here, what it does, it will remove any kind of white space characters. So white space is considered both like the empty space, but then also tabs or new line characters and so on. So this now we have removed all this trailing white space both from the beginning and the end. One thing to notice is that what happens now is that this gets evaluated, but because X is a string, and if you remember, a string is immutable, X hasn't changed. So now if I am to give you X, you'll see that it still hasn't changed. So once you make a change, you want to change this, you have to save it in a new variable or override the existing variable, right? So you can say my new variable is Y, and that's why I'm going to change. Another option is you can override the X and say, like, all right, I don't need this data anymore. It's, once I clean it, I need to clean that data. So from now on, I'm just going to work with a cleanup data. So I'm going to overwrite this. And now if I return X, it is the cleanup format. And so that's why it's important to know like which types you can change and which you cannot. And so if you cannot change it, you have to overwrite it. That's the only way to do it, right? You cannot make changes in place of where you have an element and then it gets modified, and you don't have to save it in a new variable. Okay, so let's see. So maybe we go to the example, because there's no need to kind of, so we'll have lots of opportunities to kind of to show you all the possibilities you can do with strings. Are there any questions right now?
No, but maybe not specific questions, but maybe just give people some time to digest.
Okay.
Kind of not that technical question, which is people are asking from YouTube. People are asking which Python IDE you use and which would you recommend for natural science, such as biology.
Okay, so IDE. Okay, great. Okay, so yeah, so we actually will not go that much into it. So what we're using now, Google Colab or Python Jupyters, you can call this an IDE, right? So I must say that a lot of data scientists are using Jupyter notebooks because there you not only have the code, but you also have your data analysis basically, and you can have explanatory text. So they're kind of the little notebooks, right? Like a report where you can see what you're trying to do, and you can see the results right away instead of say saving them in separate files or separate directories. And then you can kind of work on it as it goes, right? You can modify it, see the changes right away. And so a lot of data scientists use that. Now, there are a lot of IDEs. So Spider is one that I know of. I'm sure there are a lot of, I cannot even recommend any, that you can use where they kind of integrate. So you have your .py file. So they're just simple, and we'll see a few of those later. You can have those. And then, it will kind of have a similar to RStudio, right? Like it will kind of have an output window where you can see the results. To be completely honest, what I'm using these days, because I'm mainly doing data, science, data analysis, I am mainly using Jupyter notebooks with .py files, of where if I also use just simply the terminal window so use a simple text editor for .py files, so you can open it. I use Atom, but which has some syntax recognition, so it's pretty useful. You can also run code in Atom, so I think a lot of people are using that too. You can also link it to GitHub, but you can also use the terminal and execute any code file from it, right? So if you type in, for example, in the terminal window, Python, and then the code name, the code title.py, it will run the file itself. So there are many different ways to work with this. And I think it's a bit of a question of personal preference plus also what your company or your colleagues are working with, right? So often, if you go work somewhere, they will tell you, okay, this is how we do it here. So everybody does the same. And for data scientists, I think Jupyter notebooks are often fine unless things get very complex, but even then, there are ways to have, and we'll cover this later when we look at modules. There are ways to have bulk of your code in .py files and then still call them into a Jupyter notebook, so that you can see the results kind of right away, right?
Another question from YouTube is, what is the proposed workflow for overwriting variables? Is it better to save in new variables, or does it clog memory?
Yeah, so I mean, it depends on your data, right? So I'd say that if you don't need the variable again in its original form, then overwrite, right? Because especially once you have enormous amounts of data where, right, like just having it once in memory is already burdening your system. So you don't want to duplicate that, right? Because then, you have to overwrite. So I think in general, overriding is fine as long as you don't need the data and you're aware of this, right? Because there is the fear is that you don't realize that, and it turns out that you're working with processed data instead of the original data. So this is something that you have to look at the particular application, and often what we do is like when you start working, right, you think is like, I'm not going to need this, let me overwrite, and then later you realize like, wait a second, this new function actually needs the raw data. So maybe instead of me reading it again from the data file, right, like I might as well just keep it in memory if it's manageable, right? And then often you might write it that way and then realize that, oops, now I have to scale up to way more data and I can no longer keep this in memory. So you know what, I have to, right, like start a new function where, or like, right, like, or do this like a separate file where I pre-process it and save it, right? So a lot of it depends on the applications. In general, if you cannot handle the data, then yeah, obviously you cannot. So you have to overwrite or save some pre-processed data that you can handle better. Or use, of course, distributed computing in other ways. Okay, so let's go to the example. So we're going back to our speeches. So we're now focusing only on one of the speeches, so Trump. So later when we start learning about functions, we'll learn how to do it kind of in a more modular way. So we're looking at Trump. We already did this part. I have just copied it here for simplicity. So we're importing the data, reading it from the file. And what we're going to do now is use the operations and the methods for strings that we learned and for lists, so that we can already analyze very briefly these data. So what we're going to do is that we use string operators to clean up the text. So if you remember, there were the kind of new line characters. There's lots of punctuation that might not be useful for us. And then we will extract a list of all the words used in the speech. So we will split the speech into tokens, as it's known, or words. Then we will count these to estimate the length of the speech. And then we can also even look at the number of unique words used in the speech. So this kind of might give us some idea about, how rich the vocabulary is of that speaker, or how much repetitive, for example, the speech is, right? So because it could be long, but a lot of it is repetitive. So it doesn't give you much more new information. Okay, so as I mentioned, this is already copied from before. All we do is that we create a text variable where we just dump all of the text of the speech as one long string. Now here I have already written this, so I am actually going to exit the slide mode so I can scroll a bit more here. So, okay, so what we do here is that we are going to clean up this text. And to be completely fair with you, I had to do a bit of back and forth here. So I had my data, the text, and some things were very obvious, such as, okay, I want to get rid of the full stops, the commas, right? I don't care about those. But then some things were specific to this particular data. So for example, there were certain characters that just because of how the data is encoded or how the text is entered, that I had to recognize that they're problematic here. Also, I wanted to remove the possessives and the contractions. There are different ways to do this. In this case, I just expanded them to simplify things. You can also, count them as separate words and so on. But for example, another tricky thing was that there were two kinds of dashes in this data that, like, when you look at it, they don't look different, but actually they are different to the computer. So I had to also do with that. So basically what I did is that it was iterative, right? So I would replace something in the text, then look at the results, see that, oh, I'm missing this particular character. So then I'm going to edit my code, look at the results again until I got it right, at least for this particular case. So, okay, so to just go over steps, what I'm doing here is that I'm using this text method or string method to first remove all trailing characters, just in case. So for example, there was a new line at the end of the speech that I wanted to get rid of. There could be also some trailing characters at the beginning. Now I'm replacing all of the new lines with the empty space in this case. And again, that's because I don't care so much. I want to just dump all, I'm interested in the words, not so much in the, say, paragraph structure. So I'm going to remove the new lines, just read it as one text without any paragraphs. And I'm going to replace, in this particular case, this symbol that is used instead of apostrophe. So I'm going to, just for simplicity, to kind of simplify some of the later processing, I'm just going to uniform all of these characters into this. So what this does is that, each of this, so it's executed. So as you can see, I have stringed methods. So I have 1, 2, 3 methods here. And it's executed, Python executes it left to right, top to down, right? So it's first it reads the text. Now it takes the text variable and the txt variable, I should say. So the string variable removes so iterates over each character, or rather in this case, it's because the strip, so it actually looks only at the beginning and the end. But then the next one, replace it again. Now what has been processed, it now goes to it and goes through each character and looks for this new line character and then replaces it, right? And the same with the, now what has been processed here, right? So it keeps this in memory and then does the next operation. And once it's done, it assigns it, but in this case, what happens is that I'm overwriting the existing txt variable. So now my txt variable is this processed text. So to answer the previous question, now actually I have said, you know what, I don't care about the original text. I'm just going to work with the processed text. So I'm going to overwrite what I have. I don't need to duplicate my data. Okay, so what this now looks like, so let me just print it right here before the other things get executed. So I will do, again, the first 500 characters. So now you can see that I no longer have these new characters. I have this a bit weird thing of where I have 2 empty spaces, because if you remember, we had 2 new line characters and we replaced them with white space. So now we have 2 white spaces, but that turns out not to be a big problem for later. So we'll just keep it that way. Okay, so now next, again, based on the data you have, I had to deal with abbreviations. So I'm going to get rid of all possessive, just say like I'm interested in the core word, not where it belongs to that word or not. I'm going to expand all the abbreviated V, apostrophe VE to have, RE to R, and so on. And same with can't to cannot, and so on, right? So I am now expanding the word, so I know which is, which one is, I don't have to deal with these separately. And so I don't think this example has, so that won't be very useful to read this, but, and then I'm going to remove any kinds of punctuation. So as you can see here, I have still the full stops, I have commas, but now here I'm removing all dashes, I am removing quotation marks and so on, like ellipses. And so I can show you now after all of this, what happens. So now we have pretty much words, right? So I have still this capitalized, some of the words are capitalized, don't worry about it too much. But I don't have any punctuation anymore. So, so to get rid of the lowercase and uppercase, and again, this is because I'm looking at tokens, so I don't worry about punctuation. I'm interested in the kind of the words, the unique words that they used. So again, what I'm going to do is that I'm going to process this this variable, and I'm going to now just call just make everything lowercase. So again, if I'm printing this, you can see now that everything is lowercase. So now we're ready to start splitting into words. Right? So I will use the split variable, and the split method. And what split does is that returns a list. So in this case, I'm not going to overwrite, right? So I have my raw text. I'm going to create a new variable because this is a different type of variable. I could overwrite, but that's, I think, we might need this text again. So I'm going to create a new variable. This is a list of words. And so I'm going to call split on my text. And split, again, you have to read about it to see what it is. But what it does is that if you don't give it any argument here, it will split on white space. So in this case, it will be the empty space. And it's even if I have 2 empty characters, it will actually count it as 1. So that's the good part. I don't have to worry about this. So let's see now if I am to return any of these. All right, so I guess this will be too big of a list. So I'm going to just return the first 100. So now what we have is that it's exactly the same words in the speech, but now they're in the shape of a list. So you can see that, right? Like, so we have the first element is chief, second is justice, third is Roberts, and so on. And so I have no more punctuation or anything. Now, okay, so, right. Now let's see. So I have all the words. So now I can already start counting, right? So I can say if I want to see how long is the speech, how many words it has, again, given that I made these transformations, assuming that, abbreviations, I'm going to count them as 2 separate words instead of 1. This is something that you have to decide, depend on your application of what exactly makes sense here. But I can use the length function to see how many words I have. And so I have 1,436 words in this speech, right? So this includes repetitive words. If I want to see how many unique words there are, I can, so let me just print this so I save it. And I can now get the length. So first I want to get the unique words, and you do that with set. Remember, because what set does is that you dump it now the list, but set would only take the unique items. And so now we have the set of unique words. And if we count those, that will give us how many unique words there are, right? So we have 1,436 words total in the speech, and 536 of those are unique, right? So this kind of gives us an idea about the rate of repetition. And of course, the way language works is that there's some certain words that we repeat a lot, such as definite and indefinite articles, prepositions, and so on, right? So this might not be very informative, but we can start now comparing, for example, this speech to other president's speeches to start seeing what are the deviations and what are not. Right, so all of this was done with just using simple string methods, and we had a function here we could use the lamp function just to count the number of words, and then also the set function that transformed the list into a collection of unique items that then allowed us to identify the number of unique words in the speech. Okay, any questions right now? All right, if they're not, let's just continue a bit more about sets. So I use set here to find the, oh, sorry, there is one.
Sorry, there was a question about piping in Python, similar to like piping in R. If you can talk a little bit about it. It's the question from YouTube.
I'm sorry, about what? Piping?
Piping. Like a similar thing to like piping in R, whether there is a
I'd rather not
Python.
Yeah, I'd rather not talk about this right now. So
sounds good.
Yeah. So let's just go over the basic stuff about everyone, and then I'm just not, I don't know to what extent everyone is familiar with R. So I think it will make more sense for these questions to maybe go to the end. Hopefully we have time for those. Okay, so let's just briefly kind of just mention that sets could be quite useful too, because you can have different operations. They're also very efficient, just the way they're saved. But again, set gives us kind of a collection of unique elements. And if we have two sets, we can actually use, either you can use an operator, special operators that have different meaning in this case, or we can use a method, and they do the same way. So we can combine the elements of two sets, right? So that's the union. We can look at only the elements that overlap, and in those two sets at the intersection. We can subtract the element from set 2 from, say, set 1, and then we can also use the symmetric difference, right? So here, for example, we have one set, so we can combine. Okay, let's look at the difference, the intersection. So the elements that are common in the two sets. So that would be the Philly part, right? And the H, I guess. And so on, right? So this is just kind of an example that each of these different data types have certain things you can do with them because of, right, like what they allow to do. So with sets, you can actually do these mathematical operations that link to what we know about sets from mathematics. And this could be quite useful if that's what is your kind of what is required, right? Sometimes you might have to specifically transform your data into a set so that you can get the kind of the operational count that you want. So that's how we did with finding the unique words. Instead of kind of iterating through the data and looking whether we already have met this seen this word, we can use the set function that does this in a slightly different way. It does it more efficiently for us. Okay, so here is actually both the something unique about well, not unique, but it's something that is very powerful about Python, but also very dangerous. So this has to do with mutability, which I already mentioned, the fact that some types can be changed as on the go, basically, right? So you have defined your object, and you can modify it in place. You don't have to overwrite it, right? So you don't have to create a new, but this object could be mutated over time. And so this could be both good and dangerous. So, so for example, we have a dictionary here I have defined. And one good thing is that I can, for example, define a new element in the dictionary. So it doesn't exist, right? And I can say my new element is with key 3 would be value C. And now you can see that I have modified my existing dictionary here. So now I have a new definition. I can also overwrite. So for example, I would say, you know what, I want key 1 to be a different value. So I'm going to call it X. And now if I get my new dictionary, you can see it's exactly the same object that I have called dic. And, and you can see that it has been modified. So first I expanded it and I modified it, right? So this is quite useful, for example, if you're reading data, like streaming data, right? So you can just keep on adding more data to it. Now, the same thing actually with the list, for example, so I have this list, I can sort it. So I can call the sort method on it. And so this, what it does is that it sorts the list in place. So now I basically get, so this object is now sorted, right? Like I have done it once and now this has been modified in memory and that, right, like now it's a different object than what I designed and didn't overwrite it or anything, right? It was done in memory. And so this could be both good and bad, right? So you can kind of, and this is more efficient if you do it in memory in a sense, right? Like, so instead of kind of recreating everything or keep on adding new variables, you can modify it in place. And so it could be quite efficient. And actually speaking back to why Python versus R, this is one of, I think, of the advantages of Python quite often. It's more efficient than R. And one of the reasons is that it handles kind of streaming data much better. Doesn't have to bring in all of the data into memory. So you can kind of read part of data and modify it and then say, keeping only the modified part. You don't have to bring in all of the data in memory. So this could be quite useful, right? And this also allows us, especially for lists, as I mentioned, they're the kind of the power horse of Python, and there are a lot of operations you can do with lists. So you can append an element at the end, you can insert an element at a certain position, certain index. So that will give you the index and then the element that you want to insert it at that position. Everything else would be moved. You can remove an element. You can extend so you can basically add the elements from a second list to the first one by one at the end. So you can kind of merge the two lists by appending the end or extending the end with the end. You can remove items with a pop. You can sort, reverse, right? So you can do all these useful things with lists. And this makes it quite powerful, right? And very, very fast. So for example, I can append a new element here. So let me just, so what happens now is that I have modified my list, ls1, and there's a new element. I can extend to, so extend is that I can add the elements from another list. So let's say 5, 6, 7, or another iteratable. Actually, this could be even a tuple. Let's try a tuple here. So I feed it another sequence, and now it will add each element to the new to the list, right? So I'm doing this sequentially. Now my list is modified all this time. So and yes, and I can remove, I can pop items. So again, I won't go through all of these options. This is something that you can kind of study separately. One thing I wanted to mention was about the difference between, particularly when it comes to lists, between the method sort and then the function sorted. So if I called sort on this, if you remember, what it does is that actually, you know what, I will use reverse instead, because this already sorted the way I entered it. So I'm going to use reverse, which is similar to sort. So what it does is that it modifies the list in place. Now there is a function that is called reversed or sorted, right? So the equivalent. And in this case, if you notice, so the way it works is that now I am passing, instead of calling the method on this object, I am passing the object to this function. So now I'm going to pass the object into the function reversed. But what happens now is that reversed doesn't modify the object in place. Reversed, it created a new variable. And if I want to save my my changes, then I have to actually save it in a new variable, right? Okay, actually, okay, so what's, all right. So this is tricky, but what it does is actually, it creates an iterator. So actually, if I want to save it as a list, I will transform it into a list, right? But in any case, right, the idea here is that what I was trying to emphasize is that you have to be aware of, sorry, what changes your objects in place and what creates a new object, right? And when you're not sure, just test it, right? Especially at the beginning, it takes a while to kind of get familiar with these things, and always test what, so anytime you make a statement, test what the result is and what exactly it does to get a better understanding. But here, and of course, here I also have the option of overwriting, right? But this is not as efficient as the previous option of where actually I'm changing elements in place. Now I'm actually creating a new, so this creates a new list. And at this very short period of time, I have both lists in memory, right? And only then it overwrites it. So that's why Python is quite powerful, because it can do this. So if we use the method sort or reverse, it does it in memory, and so it doesn't have to duplicate your data. So that's why it's very powerful. The problem is, okay, I already have this. The problem is that this could be also very dangerous, especially for beginners. And this is probably one of the most serious mistake that any beginner can make. So I just wanted to emphasize this particularly for you. So the reason is that, so I have two lists here, right? So I have list 1, 1, 2, 3, list 2, 4, 5, 6, 7. Now, what I can do is that I can, for example, use the append, the append method to add one of the lists, the second list to the first one. So what now happens is that I am having a list that one of the elements is a list. This is completely fine in Python, right? You can have each of these elements could be something different, similar to a list in R. And you can also have lists within lists, and so on, right? So there are no limits on this. Now, what happens is that if, okay, so I'm going to print this here. Now, if I decide now later to change my list, I'm going to extend it with some new elements. So let's say 8, 9, 10, right? So now if I print my new list, 2, ls2, as intended, right? Now this is extended with 4, 5, 6, 7, 8, 9, 10. But what happens is that my list 1 has also modified now. And notice, so see what happens. So this is what I had before. Okay, I'll clean this up. This is what I had before. I never touched list 1 between this statement and this statement, but now my object has changed. And the reason for this is that when you do something like that, you're passing this object by reference. So basically, the way it works is that just we have our variables, right? So this was my list 1, list 2. And when I made a statement, I passed list 2 by its variable name. But what it does, it makes a reference to the object itself, right? So the position here, so the element in this position is exactly the same object as my list 2 variable refers to. And that's why when I change this variable, it also changed this list. So this is quite kind of unintuitive, but the key here is to remember to be very careful with mutable objects. And when you're passing a copy, so when you clone an object versus when you're passing a reference to this object, right? And so I think this is the kind of the part where you have to remember that, you know, you have an object in memory, right? This kind of, you can think of like a physical entity almost there. And then you have variable names. And anytime you refer, so you have to think of when you're referring to this particular object. And so when you use the variable name to refer to this object, then you are, basically, you're touching the same thing, right? So in this case, we're attaching this object inside here. So it is exactly the same object. I have just made a reference now to this object. And anytime I mutate this object, it will also change here. And so this is it's a bit tricky. And again, if as a beginner, if you're never sure about what's happening, just always test it. But this is like, it could be a very, very serious actually mistake, like where you don't even realize what the data is doing. But and there is a solution to this. So when you don't want this kind of, so sometimes this could be a desirable effect, right? And that's the thing with lists in Python, is that makes them very powerful. But sometimes it's not a desirable effect. And so if you don't want this to happen, you can just create a copy, right? So we already saw one way to do this. There are other ways. You can use like a method, like the copy method, but you can also just use this just slicing from beginning to the end. And so now what happens is that instead of me linking the variable name ls2 to the same object, I am now basically saying just duplicate the values here into this new variable. And so now if whatever I do to list 1 will not be affected to list 2. This is not the case if I have just made a reference, right? So now if I do that, you can see that also list 2 changes. So tricky. And again, you have to, as I said, it's both the power and the danger in Python is that you have these mutable objects that you can modify in place, but then you have to be aware that anything that links to these objects would also change, right? So, and when you are attaching things, you have to be very much aware, are you attaching to this object, or are you taking the data from this object and then copying into your new object? So I hope this wasn't way too confusing, but I felt like it's something that it's the most dangerous aspect of Python, and it's important to know about this right away, at least to keep it at the back of your head. And so to emphasize this, I have a little quiz question about what will the following program print. So we have a program where we have list 1, so 1, 2, 3, 4, 5. And now I am assigning list 2 to be the same as list 1. I'm going to modify list 2. So I'm going to replace the element at index 2 with 0. And then I'm going to see what happened to my list 1. And so now, unfortunately, that's the part where it would have been nice to be interactive, but I'll give you a few seconds to think about what would happen. And so the answer here is that we are here making a reference to, so we're passing as a reference, right? So basically what list 2 does is that now you have 2 names for this object. This is my object. Now I have 2 names pointing to it, ls1 and ls2. And when I change, regardless of what name I use, I basically modify the object itself. So this object will change, and then whether I call it ls1 or ls2, it will be the same object. So if I have changed it, and the way I change it is that I have replaced the element at index 2, which will be 0, 1, 2. So it will be this element. I have replaced it with 0. And so now this is what has happened to my new object. So 1, 2, 0, 4, 5. And again, it doesn't matter whether I called it ls1 or ls2. Right now, both of these names point to the same object. And this is something to be just aware when you do this. And when not sure and you don't want this particular behavior, then just always create copies. And instead of passing as reference here, you could avoid this by creating a copy, as we showed with the extended slicing. Okay. Questions? I think it's a good time to stop for some questions. All right. Well, if there are none, Okay, so let's move on. So we so far covered kind of the basics. So it's a lot. I understand that if you kind of, especially beginner in programming, but even if you know some programming, as I mentioned, you don't need to know all of this right away. I have included some references. Often we just look it up. Okay, I have a string. What can I do with a string, right? So you can just go to the Python documentation, see all the possible methods you can do with a string, and then figure out which ones work for you in which case. But the idea is that we have different types of objects, and we have to, different types are suitable for different kinds of data, different things we want to do with them, right? So if our data is going to change, then you should use a mutable data type that will allows you to do this more, to kind of update it more efficiently. If it doesn't, then immutable is more efficient in terms of how much memory it takes. Right, sometimes you might have to transfer from one type to another so that it does what you needed. So for example, how we had the string and we wanted to split it into words so that we can count, right? Because if you just have a string and you count, it will give you the number of characters, but that's not very as formative. I mean, in some cases it might be, right? Like if you want to see how much ink is going to take to print that speech, that obviously is more informative than the number of words. But if we want to count words, then we had to transfer into a list by splitting the words, the string into words, basically. Now, what we did so far is what is known as straight line programming, of where we were basically executing statements from top, bottom, and then left, right, right? So here what we do is that we define a variable called s. Now we start doing things to s. So we will first remove the full stop, then we revert it to lowercase, and now we were going to overwrite the variable that we have in memory. Now we create a new variable by splitting this one into words, and then we have a statement that again gets evaluated. So basically it starts left to right. The moment it hits a function, it calls the function, evaluates it, and then continues, right? So this would give us some kind of statement. So what this does is that, again, it kind of sequentially does it. Now, it sequentially evaluates all the statements. There are ways in which you can have more complex control flow. So more complex way in which you can evaluate the data. And this is done via control flow. So control flow is the order in which statements are executed or evaluated, right? So straight line program has this very kind of straightforward, the way we read pretty much, right? Like left to right, unless you of course override it with brackets, for example, similar to mathematical operations where you can give priority to certain functions. So you can use something similar in some cases in Python too. But there are different ways in which we can evaluate statements. And now we can start doing way more complex things. So these are pretty universal across all different languages. So, they exist in R and other languages. In some languages have more than these. In Python, there are only kind of three main ways in which we can have control flow. So we have branching. So the idea here is that this is also known as conditional statements. And the idea here is that you have certain tests. So you have your straight line program, you reach a test. And if your test evaluates to true, you do some code. If it evaluates to false, you do some other code or do nothing. And then you continue, right? So there is kind of a way to have two different conditions or more than two different conditions, depending. So this also already allows you to not process, for example, all data, but look for certain kinds of data and only process the ones that you're interested in. We also have loops. So here the idea is you can repeat something until something is true. So again, you have the test. If it's true, you keep on doing, and the moment it becomes false, you just exit and continue to the next line of code. And then we have function calls. So the idea here is that you can have code in different, kind of in separate areas or even in separate files that you can call upon. And you don't have to kind of define it now. You could have defined it at different periods. And what is here also very important is that you can reuse this code in multiple times. And this is how Python is built. So for example, this length function that we used, len, someone wrote it somewhere, right? So it exists on a file on a computer. And anytime you call it, your computer goes and reads what's defined there, executes it, and then comes back. And you don't have to redefine it every time you need it. So to kind of lead you through, control flow, I'm going to use one funny video from.
This is a switch bike.
For the ads, don't have ad block here. Okay, so sorry. So let's pause it. So this is Big Bang Theory again. And there are actually not that many nerdy shows out there, so I apologize for the limited, selection I have. So here we have one of the characters who is trying to make a new friend, and he's using a flow chart about that involves a lot of control flow. So just again to demonstrate to you the usefulness of control flow in programming. Okay.
Algorithm for making friends.
Sheldon, there is no algorithm for making friends.
Well, hear him out. If he's really onto something, we could open a booth at Comic-Con, make a fortune.
See, my initial approach to Kripke had the same deficiencies as those that plagued Stu the Cockatoo when he was new at the zoo.
Stu the Cockatoo?
Yes, he's new at the zoo.
It's a terrific book. I've distilled its essence into a simple flow chart that will guide me through the process.
Have you thought about putting him in a crate while you're out of the apartment?
Hello, Kripke. Yeah, Sheldon Cooper here. It occurred to me that you hadn't returned any of my calls because I hadn't offered any concrete suggestions for pursuing our friendship. Yeah, perhaps the two of us might share a meal together. Yeah, I see. Well, then perhaps you'd have time for a hot beverage. Popular choices include tea, coffee, cocoa. I see. No, wait, don't hang up yet. But what about a recreational activity? I bet we share some common interests. You tell me an interest of yours. Really? On actual horses? Tell me another interest of yours. Oh, no, I'm sorry. I have no desire to get in the water till I absolutely have to. Tell me another interest of yours.
Uh-oh, he's stuck in an infinite loop.
I can fix it.
It's interesting, but isn't ventriloquism by definition a solo activity? Yeah. I mean, tell me another interest of yours. Is there any chance you like monkeys? Yeah, what is wrong with you? Everybody likes monkeys. Hang on, Kripke. A loop counter and an escape to the least objectionable activity. Howard, that's brilliant. I'm surprised you saw that.
Gee, why can't Sheldon make friends?
All right, Kripke, that last interest strikes me as the least objectionable, and I would like to propose that we do that together. Tomorrow. Yes, I'll pay. All right, goodbye. All right. Time to learn rock climbing.
Okay, so so I hope you enjoyed this, but the idea here is that you saw if statement, so you saw branches, right? So if the person was saying no, then go to the next. Don't execute this code. Go to the next one. You also saw a loop where he got stuck. You also saw something that we'll mention at the end of ways in which you can exit a loop. You can break the loop. Just kind of an example of where this can come in handy. So let's start. So before the break, I just wanted to maybe start with conditional statements in this to kind of make this more concrete, and then we'll reiterate some of the issues. So again, this is one type to do control flow. And here the idea is that you have your code, you reach a test. If it evaluates to true, you do something, right? Certain statements. If it validates to false, you can do something else. You can move on to the next statement. So that's up to you. It could be also vice versa, right? But you have different kind of conditions, and then you exit. So once this is once the code is over. So there are 3 ways roughly to do this in Python. So you use, I already mentioned, if. So they're known as if-else statements, right? So if something is true, then do something. So what this does is by default, if it isn't true, doesn't do anything, right? You can specifically say if it is not true, so you do this with else. So if something is true, but else, that will be basically for all other cases. When it's not true, then do something else. And then there are ways in which you can also use an elif. So basically, if something is true, otherwise, if something else is true, and you can have many of those, right? So it doesn't have to be, so basically they know, and you can also have nested statements of where some of these are inside of, so this block of code could include its own conditional statements. So to give you an example, here's a kind of simple code. This is most of the code. So basically what this says is that if x is greater than 0, then print that this is a positive, I guess, number. If it's less than 0, then print it's negative. And what is left, so what is left on the else is that when x is equals to 0, right? So this is kind of all, we have covered a lot of cases with this, then print 0, right? And so I have here defined x to be -2. And so if I am to evaluate this code, it will say negative. If I redefine x to be 0, it will say 0. So basically it tests for this condition. This is false, moves on to the next one. This is false too, moves on to the next one, and basically does this. Now, if this doesn't exist, then nothing happens, right? Because I have not covered this condition in any way. It will evaluate this to false, so not execute the statement. It will evaluate this false, not execute the statement, and then just exits and nothing else. There is nothing else. Okay, so it basically starts evaluating from the top. Whenever it hits true, it evaluates the code under that statement, and then it exits, right? So if this is true already, the first statement, then it will print positive and then just exit this whole block of code. So now something here to notice, and this is important in Python, is indentation. So here, this is how Python knows that this is all part of the same block, and that's how it knows that this is the code that needs to be evaluated under this statement, right? So indentation is meaningful in Python, and you have to be careful where this is, because, for example, if this is not indented, I would get an error because Python just doesn't know what to do here, right? So Python needs to know how to interpret this. Now, so indentation is semantically meaningful in Python, and there are two ways you can do this in Python. So you can use tabs. So I can use tab now, oops. Or you can use spaces. So I can do spaces. Now in Jupyter Notebooks I'm using, actually I haven't tested it on Google Colab of whether that's the case, but it kind of doesn't matter because any tab gets transformed into a space. But to again emphasize the importance of white space, I'm going to show you another funny video. This one is from another funny TV show called Silicon Valley. I highly recommend. And what we have here is we have our protagonist, Richard, who's a very geeky programmer who is starting to warm up to a girl programmer. And they're sitting next to each other and making plans for the near future.
You okay?
Yeah, all good, great.
You know.
What?
My roommate's going out of town tomorrow, so if we want to come back here after Erlich's party.
Oh, okay, yeah, sure, that sounds good to me.
All right, it's a date.
See you then.
Richard, what's wrong?
Nothing. Nothing. Literally, it's all good. Come on.
Oh my God.
I'm sorry.
Your roommates were right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces? But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, technically, yes. I guess I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes, all right? I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. Okay, you know what? I don't think this is gonna work. I'm so sorry. I mean, like, what? We're gonna bring kids into this world with that over the heads? That's not really fair to them, don't you think?
Kids? We haven't even slept together.
And guess what? It's never gonna happen now, because there is no way I'm gonna be with someone who uses spaces over tabs.
Richard!
Wow, okay. Goodbye. 1 tab saves you 8 spaces.
Oh my God. Richard, what happened?
I just tried to go down the stairs 8 steps at a time. I'm okay, though.
See you around, Richard.
Just making a point.
Right. Okay, so I hope you enjoy that. So the idea is, yes, you have a choice. As I mentioned, it doesn't matter that much in Python, regardless of which side you're taking here. Actually, I shouldn't say in Python. It doesn't matter so much in Jupyter notebooks because it's actually all of them. They transform into tabs transforms into spaces, anyways. But I think this is a great time to stop for now. So we can take. Let me stop sharing. We can take maybe a couple of questions, and if there are any, and then we can take a 15-minute break and come back with a bit of a review of conditionals, and then we'll continue on iteration functions and classes. So maybe a couple of questions, if there are any.
There is a question from YouTube. Could Milena please summarize the differences between methods and the functions?
Yes, so this is great. We will come back to this when we talk about object-oriented programming and classes. Very briefly now, so in terms of how you write it, as I mentioned, so functions, you pass the object to the function as an argument. Methods are attached to objects, so usually use this dot operator to attach it. And so the thing is that methods are specific to different types of objects, right? So some of the methods that work on list would not work on a string, but often functions might work on more than one types of objects. So you might have the length function, as I showed, the len function. You can pass it a string, you can pass it a list, a tuple, a set, any of this, right? So that's kind of the just roughly, we'll reiterate this later, but that's the difference, that functions are independent of the data they operate, while methods are attached to the data type they work on. And so methods are specific to particular data types, while functions might be a bit more flexible. Of course, you can have the same kind of methods named the same way, doing the same thing on different data types too. So, but not to complicate things. Okay, another question? Okay, if not, I'd suggest that we can take a 15-minute break, and then we'll come back, go stretch and have a snack, and then we'll come back and continue. We can take a 15-minute break, and then we'll come back, go stretch and have a snack, and then we'll come back and continue.
Okay, so welcome all back. Let me share, what do I do? I will share my desktop because we'll be getting out of Jupyter now, so it will be best to do that. All right, let's do that. All right, so hopefully you can still see my screen. So if you remember before the break, we started talking about control flow. And we said, let's go back a bit. We said there are kind of 3 ways we can do control flow. So we talked about conditional statements. Now we're going to talk about iteration or loops, and then we'll also move on to functions afterwards. Now, just as a summary about a conditional statement, something that I mentioned but didn't give an example is that we can nest conditional statements, right? So in Python, we make these conditional statements with if, elif, and else. But then within each, you can have more conditions within it, right? So here, this code, what it does is that it looks first at the type of a variable x, and if it's a numeric type, so integer or float, so if this is true, so either integer or a float, then it evaluates whether it's non-negative, so if it's large or equal to 0, it prints a statement. Otherwise, so if it is negative, then it prints another statement. Now, if this is false, so we're not dealing with numeric variable, then it tests whether the variable is a string, and then it prints a statement, and for all other cases, it prints something else. So in this case, I have given it a variable equals -100, and it says it's a negative number, so this was evaluated as true. Then it goes into a new set of conditions, and then it goes the same way, evaluates which one is satisfied. Now, again, to emphasize why nesting is important, this is how Python knows that this will be only evaluated if this is true, right? So because this is not a valid statement if this is a string, for example. So so that's why you have to be very careful about nesting. And I think that's also the strength of Python, that it actually visually, it makes it very intuitive and appealing of what is nested in what. So here nesting helps a lot, indentation helps a lot. All right, so this was about conditional statements. We have a condition, is it true? If so, do something. Is it something else true, then do something else. And for all the cases, you can have else. And you can skip else, you can just have an if statement, you can skip elif, and then of course you can have all this kind of nested statements. Now let's move on to iteration. So now we have a situation where we want to repeat something. So you keep on, so if you remember in the Big Bang Theory episode, you keep on repeating something until your test is no longer satisfied, and that's when you can exit. And there is, of course, the fear here that we can end up in an infinite loop, which again is a big beginner's problem quite often. That's why I felt the need to show you how to exit the compiler if necessary. Okay, so there are 2 ways to do loops in Python. One is with while, and one is with for. So while, so the way it works is that while something is true, then do the code. And the other one, for, it expects you to give it a sequence. So basically it says, like, for each element in the sequence, do something. Now, to warn you, while is the one where you can end up in infinite loops, so be very careful with it. For, by definition, you cannot, because any data, I mean, unless, of course, you have like a streaming data, right, like real time. But most data we deal with is finite, right? So for each element in the data it gives it, it will have an end. So for is less prone to this problem, but while, you have to be very careful. Now with while, there are 2 ways we can use it. One is to use what is known as decrementing function. So basically we have some condition and we have kind of a counter in a sense. So you can call this a counter, this variable x, and we increment this counter with every iteration. And then we say, while my counter is less than certain value, then do something, right? So in this case, we're just printing. So we're basically starting, we're gonna count from 0, as people in Python do. And we will increment this counter +1 but we will repeat it while x our counter is less than 5. So basically we'll repeat this 5 times. Now, here's something to watch out for is where your incrementing function is exactly, and also to be watchful about whether, you know, when you start counting and whether your final condition is included. All right, so if for example, you increment, now in this case, we are incrementing, then printing, but if we print and then increment, obviously the output will be quite different. All right, so that's something just to watch. But the idea here is that as long as we have some condition that we will reach in finite period of time, then this should end and not be an infinite loop. Another way to do a loop with while is to have a conditional statement of where you have kind of a Boolean value of whether to repeat or not. And then if some condition is satisfied, you would swap, you would shift this variable to the other state, right? And that will be indication that you have to exit the repetition. So what this code does is that it says keep repeating, right? So while repeat, so keep repeating. And what you repeat is that you will give an input box to the user, so to me in this case, so you, that says, guess which number from 1 to 100 I'm thinking of. The response of the user will be transformed into an integer. And then it evaluates whether integer is within the set value I have defined, and it gives you some clues, right? And the idea is the moment you have correctly guessed the number, your condition would flip. So in this case, it will become false, and you exit the loop, right? So basically what this does, so it says, guess which number from 1 to 100 I'm thinking of. I pretend I don't know the answer. So I will put 1, and then it keeps on repeating, right? So it says you're quite far, try again. So I would do something close because I know the answer. And you're very close. And then the moment I hit this statement, I exit the loop, right? And again, this is, you can already see that there could be situations where this never happens. And that's the fear with while loops, that they might never end. So you have to be very careful and make sure that there's always an exit strategy there. Unless, of course, you're having like a service, of course, that's kind of like ongoing service that you're providing. But in most cases, for data processing, we want to be done with it sooner or later. Okay, so this was while, iteration with while. We can also have iteration with for. And as I mentioned with for, you have to give it a sequence. So, so the way it works is that for some element, so here it's quite often we name it I, but it could be anything, right? So you can call it element. So this is a kind of a temporary name you give to each element in your sequence, right? So in this case, I'm going to define the sequence now. So I'm going to write a list. And I would just say, simply just print this element. So what this loop says is that it says for each element in the sequence. So then first, in the first iteration, it gives you the first element. And the second iteration gives you the second element, and so on, right? So basically what this will do is you just print the elements one by one. Now, and again, this is clear that there is an end to this because often we feed it finite data. And so here it's less prone to basically running infinitely. There is another way to do iteration in Python that is very common, and that is using the range function. And range works, so the logic is somewhat similar to indexing as when we looked at indexing a list. And the idea here is instead of saying, having this incrementing function, if you remember with what decrementing function with x, like where you have a counter and say like, okay, start counting 5 times, and then when x has reached 5, then stop. What you can do is you can use range to say for I in range 5, so that means repeat 5 times, right? And in this case, I'll say print I plus 1. So I want to print the number. Oh, sorry, I missed my bracket. So I want to print the numbers from 1, 2, 3, 4, 5, right? And what range gives, so it's, I can give you what range is, so it's a special type of object that returns range 0, 5. You can transform it into a list, and what, you know, basically it gives you the elements, right, from index, from starting from 0 up to, in this our case, 5. And you can use exactly the same logic as with slicing. So you can, instead of starting from 0, you can start from 1, for example. You can also do in steps. So I can now going to do in steps of 2. So start from 1, skip 1, 3, but then don't include 5. So I only get 2 numbers, and so on, right? Like, so you can do this kind of stuff. So, and why this is useful? So range is very useful because you can index a list. So for example, I have my data in this form, and instead of saying for each element, I can get both the index and the element. So basically I will say, create a range variable. So basically an iterator that will give me the indexes starting from 0 to the length of my list, right? The length of my list is 4. So the range of 4 would give me 0, 1, 2, 3. Remember, 4 is not included. So these are exactly the indices that my list has. And now, for example, I can print both the index and then the element. There are other ways to do this, but this is one example. More usefully, what range helps you is that if you have 2 data elements that have the same length, then you can use the range to simultaneously index both at the same time, right? So we have 2 lists here with different values of length 4. And what I'm saying is here is that give me all the indices from 0 to the end of the list. So that will be 0, 1, 2, 3. And now you print me the first, so basically that element from the first list plus that element of the second list, right? So I kind of simultaneously iterate over the positions in these lists and can grab the elements from one list and from another. And so this is also why like range is quite useful when you use for, right? That you can use indices. If you are getting just the elements, you don't need the index, then actually there's no need to do indexing because indexing has a bit of a overhead, right? So it makes sense to just iterate over the elements themselves. But if the index is meaningful to you, where you could, you can use the same index to look up the data in some other data, to look up the element in another data set, then you can use this range function to do that. Okay, so we had while loops and we have for loops. And there are kind of some tricks to think about, like with while loops, you have to make sure you exit. That's a problem. With for, you have some options whether you always use for with some kind of sequence on iterable. So the iterable could be the range function that just gives you kind of values. So that actually allows you to count very easily. So instead, basically for I in range 5, basically means repeat 5 times. That is what it does, where if you don't use a range. And another thing to emphasize here is that, as I mentioned already, but just to make sure for beginners, that this is a temporary variable that you define, variable name that you define now, right? So basically this I exists for this loop only, and you can call it anything. Sometimes it's more meaningful to call it something more meaningful than I. Sometimes if you're just counting, then I is fine, right? Just make sure that it doesn't overwrite some other variable you might have called the same name. But it's basically, I'm going to temporarily call each element in this sequence I, and then I can do something with this. So I can refer to this element using that temporary name. And this, of course, the value of this variable changes with every iteration, right? Because I'm going over the next element, and now this I is assigned the value of the next element in the list or in the sequence. Okay. And speaking of infinite loops, as we saw also in the Big Bang Theory clip, that sometimes you need an exit strategy. So there are ways to do this in Python. So one is that you can use break to exit a loop, and you can also use continue to basically skip to the next iteration. So what I have here is that, again, I'm counting from 0 to 4 including. And what I'm saying is that the moment you reach 2, so 0, 1, 2, then don't do anything. What's afterwards, just skip to the next one. So what this will print would be, so it goes from 1, this is false, prints first element at 0, so print 0. Next element is 1, this is false, prints it. Then reaches 2, this is true. So then what it does is it skips what's afterwards and it goes to the next iteration. So it will skip here too. Now, if you do this with break, what will happen is we'll just stop the whole loop, right? So continue kind of skips what's afterwards while break stops the loop. And so this is also another way that if you're, for example, searching for data, the moment you find what you're looking for, you can just break and not continue searching. Okay, any questions? If not, we can maybe make this more concrete by going back to our example project. So again, we're looking at Trump's and Biden's inaugural speeches. Currently, we're just looking at Trump's, just for an example to see what we can already do with what we've learned. And we already managed to process the text of the speech so that we can get unique, we can get tokens, so basically the words in some kind of uniform format. And what we can do next is that we can count the number of times each unique word is mentioned in the speech. So we can see this will help us identify words that the speaker was emphasizing a lot, right? Like that, for example, that we can already give us an idea about the tone of the speech and what they found most important, what they wanted to stress. We can exclude non-meaningful words, such as articles and prepositions, right? So we have conditions where you say like, okay, we're gonna count, but if you are one of those words that we know everybody uses in the speech, in English that would be the prepositions and so on, then we don't care for those because you need to use them. They're not very meaningful. And then finally, we can also identify the most commonly used meaningful words. To emphasize to review the theme and the tone of the speech. So what I have here is so I'll just go over the code that I have provided. So let's see, okay, so all right, so what we'll do is, so the first task is that we want to count the number of times each unique word is mentioned in the speech. So the plan is that we have our text, or rather we have our list of words, right? And remember, it's a list, so it's ordered. So the words, we have entered it in sequence. So something to warn you about this is that because I already evaluated the code before, that I can basically what has happened now is that it's in the memory, right? So I don't have to rerun the code again unless I have overwritten some of these variables, which is actually possible. So we'll see if this works. If not, I'll have to go back and rerun the code, and then I can do this. But so far, we should have a words variable that is a list of the words from the speech, formatted, lowercase, without punctuation, in the order in which they appear. And so what we do is that we first initialize an empty dictionary. And in this dictionary, each value would be the word, each key, sorry, would be the word, and the value would be the number of times this word appears in the speech. And so to do this, we will iterate over our list of words in sequence. And if this word is not already in our dictionary, so it's the first time we meet this word, so you can see if so we're going to call it I, right? So it's a word, we'll call it I. So if this word is not in our dictionary, then we're going to create the value, the key, sorry, and assign it value 1, right? So this is the first time we meet it. If it is in our dictionary, so this is false, so then the rest is that it is already in our dictionary, then we're going to increment. So we're going to take this value and increment it with 1, right? So it's the first time it will be 1. Second time, now we will take 1 and add 1 extra. If we see it third time, then it's 2. We will add 1 extra, and so on. All right. So we basically repeat this for every single word. So this will end once we finish the list of words. And now what we can do, so this will give us a dictionary. So let's do this actually. I will comment this out. So I will give you the whole dictionary, which might be quite a mess here. But so we have some of these words, right? So we have the word and we have how many times it appears. So we have chief is only once, but people, for example, appears 9 times. Okay, so now what else we can do? So this is a bit more advanced, but basically what it does is that word counts items. So word counts is a dictionary. If we call this method items on it, it gives us, you know what, we can just do that. I can just do this. And so you can see that basically it gives us this object that gives us a list of tuples where each tuple is key and value pair, right? So that's exactly like the previous one, but now we have the representation of the data into key value pairs. Now, what this is useful for us is that this allows us to sort this, right? Because we have a list that can be sorted. Remember, dictionary, we assume there's some issues with dictionaries, but we would assume dictionaries is not sorted. So it's not, we shouldn't work, if we want sorted data, we shouldn't work with dictionaries, but we're going to sort now tuples in a list. And so you have to look up what the sorted function does, but if you give it an iterable, which in our case is a list of tuples, we can give it a key of how to source it. So in this, how to sort it. So in this case, we're going to say that, look at the second element of this tuple. So we're going to use the count to sort it, and we want to be in reverse order so that we get the list sorted so that the highest, the most popular words are on top of the list, right? So the list starts with the most popular words. Otherwise, it will be the other way around. So, so I can, okay, so we have sorted word counts. So we can see what happens after all of this. I will just take perhaps the 10 most common words. Sorted word counts, okay. Mistaken how, okay. So here's what we get. So we get the 10, I guess it again to make this bigger. Okay, so the 10 most common words are, as predicted, there would be actually words that are known as stop words in text analysis. So these would be words that are not very meaningful. Of course, in different speeches, this might not be, you know, they might be meaningful. So I'd say like in this particular speech, we is a meaningful word since, right, like it kind of expresses certain tone about we as a nation or we the people. But then others like and obviously is not that meaningful. So, so this is what we get by just counting how many words, how many times a certain word appears. And we know that there was repetition in the speech, right? And we also know that in all speeches, we have certain words that we use more than others. So now what we're going to do next is that this is fine, but again, we probably want to exclude these words so we're not distracted. So we're going to exclude these stop words. And we will now create, so I have created a list of some of the common stop words that are not common here. There are lots of, there isn't really a universal list for these things because often, as I mentioned, depends on the context. So I just have, you know, manually created a few that I could see that I wanted to get rid of. And, you know, of course, you will do this more systematically once you deal with real data. But for an example, what we're going to do now is that we will create an empty list with common words. And we will iterate over all of these, basically our sorted word counts, right? We will look at the first element, so that's the word itself. And if it is not in this list, so basically if it's not a stop word, and if it is a common enough word, we will actually append it to the list. So we'll append the whole count to our list. Otherwise, we will stop. And so break means that we will basically exit the loop. And so why we can do break here is that, remember, our list is sorted. And the moment we reach words that are appearing for fewer than 2 times, so appearing 1 time, then we can stop because the rest of the list would be words with that appearing only 1 time, right? So in this case, we can kind of make use of this break clause of where we don't have to iterate through the rest of the list because we know it's sorted, and we know that whatever comes later would be not satisfying this condition. So there is no need to go to the end. So this might be no more complicated than normally, but I just wanted to kind of demonstrate the use of what we learned so far. Okay, so now what common words would be? It will be a list of tuples like this one. So in a sense, we'll get something very similar to what this part here is showing, but now we would have removed these, the stop words, and also we would have removed the ones that appear only once, because let's say that, we're interested in the ones that are kind of more repeated concepts. So if we run this and we can, again, show maybe now, again, the top 10. So now we can see that we have removed these top words and we have we, our, will, America, you, all, American, there, your, people, right? So again, you can think of some of these common, but obviously they're meaningful here, right? Like we, our, that is kind of creating a sense of unity instead of you, which also exists, right? Like where it is, or I, right? Like where it obviously talks about yourself. So, okay. So again, this is just a demonstration that now we can, what we do is that before what we were doing with the methods we were using with strings is that we were iterating over every single character or every single word, and then, replacing or removing. But now we can have conditions. So we can say like, well, okay, I don't care about this particular element, just disregard it or do something else if it fits in this condition. And then we can also, in this case, iterate over just even part of the elements. So we can just say like, all right, at this point, I'm done. Get out of here. So that's how loops and conditionals could be useful. Okay, time for questions. Anyone out there still? No?
No questions yet.
Okay, good. Thanks for responding, because I was a bit afraid for a second there I might be talking to myself. Right. Okay, good. Okay, so if there are no questions, then let's go to list comprehensions. So this is, some people, think it's a bit of an advanced topic, or some people don't like them. But I think for any data scientist, this is an important thing to be aware of. So this is a very unique kind of Python syntax of where you can do loops and conditionals to create a new object, so a new list. They're useful because, because they are actually implemented in C, and which makes them very fast. So if you are to write exactly the same code, but in typical Python syntax, it will take much longer. And so these are, and often actually, very often when we process data, we want to create a new data element that has only data object that has like only parts of the elements, for example, or has transformed the elements. And so actually they come in quite handy. And also they come in different forms. So there's a list comprehensions, there are dictionary comprehensions, there are set comprehensions, and there's also iteratables, I guess, that you can write in very similar syntax. So it's a bit, it's a slightly different syntax, but the idea with loops and conditionals is the same. So warning, this could be quite confusing, especially for beginners. Some people hate them. I think they actually could be quite handy, and I have used them very extensively and just radically speeded up my code. So, right. So here is a segment of code. So what this does is that I want to create a new list that contains my data processed in some way. So my data is elements starting from 1 until 10. So we start from 1 until 11, but without. And I want to append I want my list to have the squares of all elements from 1 to 10. And so if I run this, right, like I get basically the squares of the first 10 numbers, whole numbers. Now, if I am to write this, I can write all of this in one line of where I will start. So basically it tells me, give me answer will be a list. and each element of the list will be the square, where the square of the x will be for x in, so basically this will be this condition, right? So you can see it's almost the same syntax, but the structure is different. So basically this tells me, give me a list. We know the square brackets are designed. Each element is x squared for each x in from 1 to 10. Right, so now if I am to print the answer, the new answer, actually I'll name it something else so that we know they're separate. So I'm not, so it's exactly the same thing, right? So again, so this is it's called a list comprehension, where you're creating the list on the spot. You're not using this kind, you can see that it's just one line instead of what is here, 3 lines, right? It's one can argue once you get used to it that this is even clearer. And as I mentioned, it is almost always faster. So now, of course, these things could actually get very, very complicated. You can do like if statements, for example. So I can do the same. So by the way, I didn't mention this, but this double stars just means to the power of, right? So we can, for example, do now every even number. So we have a condition there. So for x in range, again, 1 to 11, but now we'll have a condition that says if the modulo, so that's a mathematical operator that says the remainder, if I divide x, an integer x by 2, if the remainder is 0, which is a way to say basically if it's an even number. What did I know? Oops. Okay. Equals. So yeah. So that's so here I made this mistake of using the assignment operator instead of the comparison operator, right? So so you have to make sure that you have your comparisons correctly. Okay. So what this does is that it iterates. So for x in range 1 to 11, so it starts from 1, checks whether it's a even number. So 1 divided by 2. Modulo is 1, so this is false, so that does nothing. If it's true, so the next number 2, to divide it, modulo of 2 is 0, so that's an even number, so we're going to take the square and put it in the new list. So this gives us the squares of the even numbers from 1 until 10. Okay, and of course, you can also do even more complicated things where you can have multiple nested loops. So similar as we nest conditionals, we can nest also loops, right? So iteration, you can have nested loops. So for example, I can have 2 iterations. So I can iterate over 2 lists. So one is for x in a list. So let's say this list is just made of letters. And then so for each x in this list, and then for each y in another list. So let's make this one with numbers. Actually, I might have, let's do this. We'll have to do string here because otherwise it might get confused. Then give me x plus the string representation of y. So what it does is that it's pretty much like 2 nested loops. So first I started with this loop. Now x is a. And now I'm starting for x equals a, I'm starting to iterate over y. So now y becomes 1, then becomes 2, then becomes 3. So we have a1, then a2, a3. Now I'm out of this loop and I'm going to the next x value, b, and so on, right? So again, so you can have, so one can argue this is quite, could become very hard to read. But again, the idea is here is that this is only one line instead of what would be 1, 2, 3, 4 lines, right? Because we have 2 nested loops, plus we have to define the empty list at the beginning and then start appending to it. And so this will be, it's more compact and faster to run. And if once you get comfortable with it, it will be quite useful. And of course, you can have dictionary and set comprehension, as I mentioned. So for example, this is a dictionary comprehension where we're creating a key and value pair. So notice the syntax that we are using the curly brackets and then the colon to represent that it's going to be a dictionary. This is going to be another dictionary. So now what we're doing is that we are iterating over tuples, and we are expanding. So the first element from each tuple would be X. The second one would be Y. So we're going to call this X, this Y, and then we were going to transform it and make a dictionary out of this. And then we can have a set. So the last one is a set. So notice that we're still using the curly brackets, but there is no colon here. So that's how Python knows that it will be a set. And so we have some string, but then it only gives us the unique elements, right? Like, so first it creates this, iterates over these elements, gets the lower, and then makes it into a set. So it gives us only the unique elements in whatever this was. Okay, so again, this is kind of just a different way of writing loops that is very unique to Python and quite useful sometimes, especially if you're trying to optimize code. Of course, this can never compensate for just badly conceived code. So if you're doing unnecessary loops or you're having nested loops when there is a much more efficient way to do this by, for example, iterating through your data once instead of 10 times, then this will not really save you in most cases, right? There are limits on what this can do. But if you have to do that loop, doing it in list comprehension might be faster. So to give an example, this is some of the code I had before about finding the common words. And we were iterating over the sorted word counts, and we were saying, first, make sure it's not a stop word, and then it also occurs at least once, and then add it to this list. So in this case, we're creating a new list, so we can just use a list comprehension. So if we are to do this as a list comprehension, I will start writing it the way I would normally. And sometimes, honestly, the beginning is also easy to maybe write it out like this and then translate it in a sense, right? Because it's a bit, this is a bit easier to think about it in these ways. But basically, we start with the loops, right? So we have for I in sorted word counts, I want to add I, right? So give me I for each I in sorted counts if, so here the conditions come. So if I is not in stop words, so if it's not a stop word, and in this case, I would say, and if the count is greater than 1. All right, so sorted word counts was a list of tuples. So each I has first, which is the key, the word, and then second element. So I will index it as the first element and the second element. And then I will put these conditions. Now, okay, I can do the same as before, just print the first 10. All right, again. Oh, and sorry, I had this extra if. All right. So yes, so it looks exactly the same as before, right? So we just kind of overwrote the variable now. But one thing to note here is that here we couldn't include a break statement. So what this does is that it will actually iterate through all of the elements, right? Like, so it go to the first. So the moment it hits an element that is 1, then it will this will be evaluated to false, but then it will go to the next element. So there are some limitations on what list comprehensions can do, but even in this case, in actually quite a lot of applications, this will be still faster than if we have code like that, right? So again, it depends on the data you have, how large it is, what are you doing with it, but often list comprehensions can be quite useful, and you might have to do some benchmarking to figure out what might be the most efficient way to deal with this. Okay, any questions before we move on to functions? All right, if not, let's move on to functions. Okay, so the idea with functions is that, as I mentioned before, we can use somebody else's code basically, right? Like we can first segment our code in different modules, and we can call onto the functionality of that core code without even understanding what goes in there. So we already did something like that, right? Like, so we use this function, for example, length. There are also others I didn't talk about, like max, which gives you the maximum value, the element with the maximum value in a sequence or a collection. We had the range, there is the open function if you want to open a file, for example, and so on, right? So this is a function that some Python developers wrote as part of the base Python distribution. We don't have to know how they were written. We don't have to rewrite them every time we need to use them. We just know what it takes and what it returns, and that's how we use them. Now, of course, you can write your own functions, and that's why we're learning about this, because often you might have something very specific to your application that you need that none of the existing functions already do, or you have a whole kind of sequence of operations that you want to modularize that you can apply again and again on different kinds of data sets, which is what we're going to do here, because the analysis so far we did on the Trump's article. Now, if we have functions about this, we can call these functions and do it on different kind of, I called it article, but speech, right? So we can do it on any president's speech, this kind of analysis. So the idea is that once you modularize this code, you can call it repeatedly without copying and pasting it and manually changing parts of it. And of course, that's also a very efficient way to break a problem into multiple parts, work with others, borrow their work, both your collaborators or people online, right? So, and that's kind of the part of all these libraries and modules that we're using, for example, for text analysis or for network analysis, machine learning, and so on, is that somebody wrote them. You don't really need to understand what exactly algorithm they use to implement this most efficiently, but you have to understand what the function does. So, so that's what we'll look at now. How do we define functions in Python? So in Python, you use the def reserved word, then you name your function, and then in brackets, you have a list of parameters. This could be empty. So some functions might not take any kind of parameter, so you don't need to specify anything particularly. And then again, indentation, very important. That's how Python knows that this is the body of the function. Oops, sorry, I opened this. The moment you re-indent back to the here, you know that that's the next statement, right? The function definition has ended. And when you call a function, the way we already did is that you use the function name, and then you pass in arguments that will be bound to this the list of parameters. There could be default parameters that you don't have to put any arguments for. You can so there are different ways to kind of call a function. Sometimes you don't have to even pass anything. So so as I mentioned, when we call the function, the arguments, the parameters bound to the arguments, right? Like, so for example, we have a function here that we have defined for abstract values x and y. What this function does is that this is called the function specification, or this type of triple quoted string is also known as a docstring in Python. And this is useful to tell us what this function does. And this is, in a sense, provides the interface for users. So usually it should include what kind of data it takes and what it does and what kind of data it outputs, right? So that you can use this function even if you don't really need to understand what's happening here, what are the guts of this function. But what this one does is that it will take two arguments, x and y. It will assume that they're numeric types, so it will trust the user that they've given it correct data. And it will just return the larger of the two. So if x is larger than y, then it will return x. Otherwise, it will return y. Now, obviously, this function is not perfect, because what happens if x equals to y? In this case, it tells you it will return the same element, right? So it doesn't give you a warning. So probably the function specification should have been a bit more specific. But this is, right, so the function is defined in this kind of more abstract parameters. And when we call the function, we now give specific values to these parameters. So these are the arguments. So we will pass 3 to be the x. So now within the function, we will bind x to become 3, and then y becomes 4, right? And so this will be evaluated. And so in this case, it will give us the larger. So it will say, okay, now x is 3, y is 4. It will evaluate it, and then it will do what it does. Now, notice the statement return. So this is again reserved word in Python. So a function ends, stops being evaluated the moment it hits return. Now you can have functions without a return statement, in which case by default, they will give you none. And that is the case for some of these functions and methods we looked at, of where they were modifying our data in place. So they don't return any new value, but they make changes. And so in that case, they would be returning none. So, so just to summarize, so you have the return. So the return statement executes, just ends the function, so exits the function. You also, of course, would end if you don't have any more statements for that. So for example, here we have the same function. And what we do now is that we don't have, so we have, which again is not very well written function, but in general, just for the purposes of an example, we have a condition that they're not part of the same statement, right? So they're two sequential if statements. So unless you exit, it will still evaluate this one, even if they're mutually exclusive, right? So there are more efficient ways to do this. But basically what happens here is that if x is larger than y, it will return x and then exit the function. If that is not the case, it will see if y is greater than x. And if it is, it will return y. If not, so basically if we have x and y are equal, this is the only statement that hasn't been evaluated yet, then what will happen is that it does nothing. And at this point, it has reached the end of any code, right? So it exits the function and returns none, right? So if we have this, so we are here in this case where y is greater than x, so we return 5. Otherwise, right, like if this is 7, we will be in the first. But if we have the same numbers, then it returns none. Now, if it does nothing, right? But if I am to print it, you would see that it will be none, right? And so just kind of to get an understanding that if you can exit a function with return, but you can have a function without a specific statement, return statement, in which case it will always return none. So function always returns something. And it will not stop in that case until either reaches return or just ends all code, basically, right? Because exhausted all code. Okay, you can have functions with returning multiple values. So in this case, right, like so functions can take multiple arguments. We can also return multiple values. So for example, we have 2. We can have, all right, 2 and 3. So we are given, so that's how we write it, but actually you can also explicitly say, give me a tuple, but basically what it returns is a tuple. And now you can also actually unpack this tuple. I think we already saw some options of where you can unpack this. So basically now say, like, I know it's going to return me 2 values. So I'm going to call the first one x, the second one x, and then I can just return one of them, for example, right? So it gives you the 1. So we can have multiple arguments. So we can have multiple returns. Now no returns whatsoever. We can have multiple values returned. We can use a function to modify data in place, so it can create and return a new data. You can also have this kind of positional versus keyword arguments. So this is kind of a bit a complex argument, but the idea is that you name each parameter with a name. And then when you feed the function, you can either use positional position, so where you say, okay, if I'm going to order them and I give it exactly the same number of arguments, then Python would assume that the first argument binds to the first parameter, second to the second, and so on, right? But I can use the keyword. So I can, if I know what the names of these parameters are, I can use them and actually feed them in different order. So this could be useful when you don't necessarily know the ordering, for example. And then I can have a mix of those, right? So I can have, I can pass some as positional. So if I don't specify what it is, it will assume it's the first one. And then the other ones, I can actually name them explicitly. And then this also comes in handy when you have default parameter values. And so this is quite useful because you don't have to, some of these functions have a lot of parameters, and sometimes you don't need to know what they are, or they're not always the case. They're always valid for your particular situation. And so you don't have to write out every single parameter, right? Even if you don't even realize what they are, you can call a function. They can have default value where you don't have to worry about it. And then you can just use the ones that are helpful for you. So just here I have an example with something that creates, I guess, a better better formatted string to print it. And then I have some kind of default formatting, and then you can overwrite this, or you don't have to, right? So if you don't specify, then it will just use the default values. So this is pretty universal across a lot of languages in terms of functions, right? There are a lot of them. I mean, of course, there is something specific about the formatting of how you declare the syntax, but in terms of how they work, it is relatively universal. Okay, any questions? Okay, so if you're new to programming, something to know is that, which again could be a bit confusing, but that a function defines a new name scope. So the idea is that when I mentioned that how we don't have to rerun code that we have run in previous cells because it is currently in memory and the compiler knows that I have defined the txt variable to mean the text of the speech, for example. The idea is that there is a name scope. So there's kind of a space that defines all the variables, all the data that I have created, right, in this current session. Now, what a function does is that it has its own separate name scope. And so the variables you create inside of in a function are only belong. So the moment you exit the function, they don't exist, right? So it creates this temporary name scope. And this could be quite useful because it doesn't mean that every single thing you write has to have a unique new name, right? So that you don't get confused, that you can actually reuse some of your favorite names that you use, or something as simple as i's or x and y's to within functions, and they will not overlap with anything that's outside of the function. So here is an example of where we have a function that takes two parameters, x and y. And within the function, we will increment x, and we will create a variable that adds x and y, and then we'll return this new variable. Now, outside of the function, we have defined x to be 1, and then we will call this function on this x and on 5. Now, if we are to print x, so notice that in the function x is incremented, but the value we get is the value from outside of the function. And again, this is to indicate that this x is different from this x, right? And this x only exists within the scope of the variable. Now, if we do this with z, so if we're trying to do z, what we'll get is we get an error, because again, z is only defined within the function. And now we're calling this function, but there is no definition of z outside, right? So there's no way for us to access, in this way, right? So there are other ways to do this, but in this way, there's no way to access z here. So you just have to be kind of aware of what is belonging to the function and what is outside. Of course, this gets more complicated once you start passing mutable objects as a reference that gets changed. So if this was a list, actually it will be the same list, and you make changes to the list, then you are changing in place. So there are a bit of complications that we cannot go into details, but overall, right, like that you can, if you define a new variable within a function, it only belongs there, and you cannot access it from outside normally, right, with the standard syntax. There is also the possibility of having a global scope. So anything that's outside of a function, and it's, you can see it's aligned as much to the left as possible. This is a global variable. And so actually this is a variable that you can access both within a function and outside, even if you don't pass it as an argument. So in this case, this function accesses this global variable and it just prints it. That's all it does. and I haven't passed it on to it, right? So I could pass it as a local variable, right? Like as an argument, but that's different. And in Python, typically we would have, we have capital letters reserved for global variables to just visually indicate to you that this is something that you define. So this could be quite useful, for example, if you have some kind of global settings that you need to reuse in say for plotting or something like that, right? Like that you could preset them and have multiple functions that will rely on them. Okay. Are there no questions?
Hello, I'm just following your course. Could you please summarize the differences between methods and functions?
Yes, so there was already this question, and I would like to, so at the end, we're going to talk about classes. And I already answered this question, but we would iterate it a bit more. But again, just very briefly. So a function takes a data as an argument and then manipulates it. And the function can sometimes work on different kinds of data, right? So it can, for example, the length function we saw works on lists, works on, so any kind of sequence, right? Like, or actually collection too. So anything that has length, right? But a method belongs to a certain data type. So for example, the .sort method only exists for a list, because a list, and what it does, it modifies the list in place, because for example, you might think it might work on a set, but a set is not an ordered sequence. So you know, sorting means nothing. It won't work on a tuple because you cannot modify a tuple in place, right? So basically the method belongs to a different data, to a specific data type, while a function feeds the, basically takes the data and can take sometimes multiple types of data. As I mentioned, this will become, it's in the last slides, and that was why it's important to reach to classes, because I think then a lot of these things will come together, so for you to understand. So hopefully, yeah, if you hang on until the end, I think it might become a bit clearer.
Thank you so much. Thank you.
Okay, another question? All right, so let's go back to our example. So at this point, actually, we're not even going to do any new manipulations of the speeches, but what we're going to do is that we will put all the code we already have written. So remember, we were tokenizing, then we're looking at the length of the article, the unique words, we counted which are the most common words. And so now we're going to put all of this into functions. And this allows us to do this for in our case, just two different speeches, right? For Trump and Biden. We don't have to copy and paste code to do it again. We'll basically call the function on two different data types. We'll feed the data to this function. It will do exactly the same thing because the data is similar, and it will give us the results without us having to copy and duplicate code. So there's a bit of rewriting I did just to, again, introduce some new concepts. So this will not be exactly the same, but the idea is the same. Okay, so what we're going to do now is that we're still going to open our data. I'm also importing another module for strings. You can look it up here, that we'll use to get the punctuation symbols. So now what I'm doing here is that I will define our stop words as a global variable. So notice the capital letters. And that's because I want to define it up front. I mean, sometimes you might also like bring in it as an external data. That's probably how you do it. That you have like kind of a list of stop words that's much larger than this. But so it will be outside of a function, right? So it's kind of like external data I'm bringing. In this case, I'm literally typing it. And then my functions will call onto it as a global variable. And now I have two functions. So one is get tokens. So this one takes a URL and it will open the URL, read the data. So that's something that we already saw. So basically it creates, it adds all the text, and then it will format the text as we did before. And then it will split it into words, lowercase words without punctuation, and it will return you this list of words. So this is exactly what I did before. The only difference that kind of optimized this code a bit more, one is that, for example, I use this string module that contains kind of I guess a data object called string punctuation that is basically includes a number of punctuation marks. So I don't have to manually define all of them, but then it didn't really work in this case. So I had to add a bit more. So you can see that what I do is that so this is a string of punctuation marks, right? That they're trying to be exhaustive, but I'm making it into a set so that then I can use the set operation and combine it with my own additional set of others that appear in the data I have, right? So I had to customize a bit. So I use something that's already there. I had to customize it a bit. So now I have a more extensive list of punctuation marks. And now what I'm going to do is that to make it more efficient than before, because again, what we do here is that for each of these replaces we do is that each of them go through the data, go through every single character, and then the moment they recognize this, then they replace it, right? So each of this is a loop in a sense through all the characters. And here, instead of doing the same with the punctuation marks, I will optimize it a bit, and I will do only one loop. So this is my loop here. So again, you can see that I'm using this iterable kind of iteration syntax that's similar to the list comprehensions, but it's technically, it's a loop, right? So basically I'm saying for each character in my text, if the character is not in the characters to exclude, so these are the stop words, then just give me the lowercase character and just join it into a text file, right? So basically what it does, it goes through every character, checks if it's a stop, sorry, so this is not stop, this is the punctuation marks. It checks if it's a punctuation marks. If it isn't, then transforms into a lower character and then keeps on appending it to this this string, right? And so in the end, I will basically have the text again in a string format where every character has been checked whether it's punctuation or not, and if it's not punctuation, it's lowercase. If it is punctuation, then it will be removed from the text. And this is all done with one loop, right? With an in statement, which as a matter of fact is a second loop, but it will be more efficient than this one, especially if you have more data. Okay, so this is just a bit of a kind of a second iteration to improve my algorithm, but even the previous code would have worked. You could have just literally copied and pasted, not forget to indent it, and not forget to change any variable names if you need to. And so once we have our token, so that will be a list of words, then we can do the word count. So now I have a new function that takes the tokens, and now it's exactly the code we had before, where we now are returning the sorted word count. So this will be I have to specify a dictionary where keys are words and the value is the counts of the number of the time is repeated. Okay, actually, I think this is incorrect. Yeah, so see, my function specification is correct because I think this returns, this returns a list of tuples. So this is the part where this is important to specify this, because a user would read this and expect a dictionary when actually it is a list of tuples, right? So you have to be careful about the function specification. Okay, but so this is exactly the same code I have done. I'll just put it in a function where I can feed it, basically can reuse the code to run these functions on multiple kinds of data, right? So here I'm going to get the tokens for the Trump, and then do the same exactly for Biden's data. So all right, so let's see. So we can, so if we run this, and I can, just to make sure it works properly, I can print the first 100. Okay, that's too much. Let's print the first 10. Okay, so yeah, so this is the speech of Trump, and then we can do the same with Biden. So we have already created variables that has all the tokens, and we have now his speech that also starts with calling the attendees. Okay, so so now what we can do is that we can compare the two, right? So now we don't have to copy paste this code. We already have our tokens. And so we can do is that we can say print the length of Trump's speech and then compare to the length of Biden's speech. So we can see which is longer, for example. Okay, so we can see that Biden's speech was much longer, right? So it's 1,436 words for Trump, 2,382 words for Biden. So his was longer. Now we can look at also the number of unique words. So we can, instead of the length of the tokens, we're going to do a set. So remember, set transforms the list into unique items. So now we're looking only at the unique words. And so this kind of gives us an idea of how much content there was, right? So for a longer speech, of course, Biden had more unique words, so he had more to say. But for example, we can try to normalize this. So I'm going to actually divide, let's see, to see how many times on average a word was repeated. So I will divide the number of total words by the number of unique words. Okay, let's not forget to change this to Biden. So now it would just gives us a number of how many times each word was repeated. And so you can see that overall Biden was more repetitive. So now, there's some issues here, like if, probably he's more repetitive because he was using more of those stopping words, right? So obviously you need to do a bit more intense analysis here, more informed, but just kind of overall, even the simple things we have learned already allow us to look at some data and make some comparisons. Now, this was just for the words. Now we can do is we can look at the word counts. So we have our function get word count, and I will feed it, for example, the tokens, right? So this one takes tokens, but in this case we have defined that Trump's tokens are called in a variable Trump tokens. And to save this, I would call this Trump word counts. And I will do, and I will do the same for Biden. So now just rename the variables. So Biden, obviously, right, like if you are doing this on a lot of data, right, you're going to write a loop that goes through this, or its own function that would iterate all of this. But just already we're modularizing here by using these functions and not having to copy and paste everything and manually change the links every time, but we can actually just call the function with the right parameters. Okay, so what we can do is, so we have Trump word counts. We can print Trump's, maybe the first, I don't know, let's see, first 20. And we will do, I will print actually an empty line just to make it more visible, and we will do the same with Biden. Okay, so now we want to see what this will allow us. So we use this function to allow us which were the 20 most common non-stop words in those two speeches. And so this is for Trump, the first one, the second one is for Biden. And so you can see that, for example, Trump used a lot of we, our, there is some you too, right? And you can see, for example, which I was surprised, by the way, I mean, I'm not a political scientist, so I just took this example because it's easy, but I was surprised, for example, to see that Biden used a lot of I and my, right? So it was all about his story and on what he's going to do, while Trump, just looking at this, you can say that he was more about, not knowing anything else, right? That it was more about, we as a group. Although there is also you, so that's interesting, but much less about himself than in Biden's case, right? And so you can do this kind of very simple, very straightforward analysis. As I mentioned, this is just using basic principles from programming. Of course, if you do proper text analysis and you take, for example, when you take the text analysis course, which my colleague Ken Benoit will be teaching in this particular summer school, then what you do is you're using someone else's functions that would be doing more or less this work in more or less this manner, right? But you don't have to worry about how exactly they have optimized cleaning up the text, right? So that's kind of the beauty of using functions, and especially somebody else's functions, is that you're delegating some of the effort to others who have already worked on it and thought about it more carefully than you have the time to do. But but this is kind of important to understand the basics, I think. And sometimes you have a very specific application. You may have to tweak code by others or write your own code from scratch almost. Okay, so unless there is a quick question, I wanted to go to modules now. So very briefly, so here we have the functions. We have already modularized, right? Like, so we have broken a kind of this long straight line programming code we had with loops and lots of text. Now we have broken it in smaller chunks and functions that are kind of coherent, meaningful. But we can do this even further where we can take some of this code outside and put it in a file, in a separate file. So once you have very complex kind of tasks, you can now not only break it in functions, but then also you can break it in modules, which are done by .py files. So I wanted to show you that. Let me see. So where I am now, so I hope you can see my screen, because I was sharing the whole screen, not just the application. So hopefully you can see now my folder here. So where my file is, so this is Python intro. That's the same you'll see on the GitHub repository. But there is another file which I have called speechanalysis.py, and it's a .py file, but you can open it in any simple text editors, not Word. It will mess up lots of things, but I'm using Atom. There are others. And what I have done now is I have copied and pasted this code with some minor modifications. Again, the only modification I have now is that I have a separate function for getting the file. And here what I do is that I allow for it to be both from an URL or local. And that's because there is a difference between the files on GitHub and the files on Google Colab because of how Google Colab works. But more or less the idea is the same, right? So you can recognize these functions that I already have in the other file. But now what I've done is that I have put this in a separate file. For simplicity, now it's in exactly the same directory as my Jupyter notebook. And what I can do is that I can import this. So when you do the import statement, that's what it does, right? So it kind of takes code from this file, you say where it is. If you don't specify specifically, it will first look for it in the local repository, then it will look at in the baseline Python distribution. There are ways to also where you can say specifically where to look at. The problem, I must warn you, is that with Google Colab is that you have to specifically upload this file there, because in your instance, like online instance, so this will not work right away, and you have to find the file, download it, then upload it there. So, but the principle would be the same overall, that if the file is in the same directory, if you use, if you use import statement, you can import it. So what I do here, so one way to import is that what I do is, as I say, import speech analysis. And now I can refer to functions or data also, like the global variable. I can also access the global variable from speech analysis by doing speech analysis.get tokens, right? And so in this case, I'm doing exactly what this, but in this case, we are reading this file. And as I mentioned, because I haven't specified where it is, Python will by default look for the same directory. If it doesn't find it, then it looks in the baseline distribution. And then if it doesn't, then it will tell you that it cannot import it. And this will not work, unfortunately, on Google Colab unless you do some extra steps of uploading this file. And again, in this case, this is a file that's a module that I defined, but we did exactly the same when we were importing these other modules, right? So whether it's something that you have written, or these are also .py files, right? This is also .py file. They're just part of the core Python distribution. So this is kind of just how universal it is that you can, and this is how also this kind of open source development works too, that like any one of you can contribute a .py file and expand, create your own library or create your own module, and you know, or even contribute to the core Python distribution. Basically, there are different ways to import. So here we just import, and then anytime the name, then the whole name, right? And then anytime we want to refer, you have to use the dot operator to say that now give me this function, but take it from the module speech analysis. You can use an acronym. So I would say import speech analysis SA. And now instead of writing speech analysis every time, I can do SA.get tokens. And you can also do this where basically you say from speech analysis import either star, meaning everything, or you can even say specific functions. So I can say, just import me just this function. I don't need everything. And now I can just call this function without having to refer where it comes from. The problem is that if I have a function that has the same name defined here, or if I have another import with the same function name, things can get really messed up, and you might be confused of what is the last import and what's class definition. So sometimes, yeah, if it gets complex, it's best to use at least an acronym to be clear of what is what. Okay, but again, this is a way to segment your code in multiple parts, but it's also a way to borrow and reuse code from one project to another, and more importantly, from other people's projects, right? Like, or from Python in general. So Python itself has a lot of useful modules. So here I have listed some that are particularly useful for data scientists. So we have regular expressions. We have a module for handling dates. We have very simple math, probably too simple even for most data science applications, but there are other packages. So package would be kind of a more, so modules, these are kind of simple, usually just one .py file, so they're kind of more contained. But there's random that is very useful. So random generator. There are ways to deal with your directory paths. There is a serialization, which I'd love to talk if anyone's interested. Anyway, so lots of those, right? And then beyond that, so these often come installed with Python with the kind of the core distribution. But beyond that, there are also packages. These are kind of larger collections that are provide lots of various functionality. So you would probably encounter some of these in some of the courses you are taking in the summer school or in the future. But NumPy is one for scientific computing that I mentioned already. So it's great for matrices, for example. There is Pandas, that's kind of the workhorse for data scientists in Python. So that's for kind of table-like structures, right? So if you ask me, it's pretty much R translated into. So if you, that will be the package that makes you more at home if you're an R user. There is stats models for very simple, unfortunately. So R is much better about statistical modeling. Stats models a bit basic, but for example, there is scikit-learn, which is for machine learning, and there actually Python is more advanced. NetworkX for network analysis. Again, it depends. Python is better for kind of larger data sets, but there are lots of things that are not implemented in Python, such as exponential random graph models or stochastic actor-oriented models and similar models, more statistical models. So you may have to often, if you do network analysis, you may have to use both, basically. Matplotlib, it's for plotting. There's Seaborn, there are lots, right? So you might have heard about some of these, or you will hear about this. But the idea here is that these are packages, so they're more complex, but they're pretty much a collection of .py files where kind of a more complex tasks in certain realm, right? Like so machine learning, for example, different machine learning algorithms and data processing algorithms have been packaged together. And then you can import this and reuse this code for your particular data. You can also technically edit this code, right? So you can override these things. You can have a local copy and modify it for your needs. Or of course, you can actually push or whatever, right? Like you can attempt to have these modifications and improvements even to contribute to the open source software in the future. So again, so this kind of right? Like we started with functions, then you can put them in .py files, but as a matter of fact, anytime you import something, this is a .py file. So in a sense, you already know how to write modules and packages. So that's why functions are quite useful, and understanding modules. Okay, can we pause maybe for questions before we move into objects and classes? Okay, no questions?
There is one question from YouTube. I have a broader question on workflow. I know it is possible to work with Python and R together, but if I wanted to use ggplot2 from R on objects that I manipulate in Python, does Jupyter Lab allows it?
No. So yeah, so Jupyter, yeah, so it's interesting. So Jupyter actually by design, it can work with many different programming languages, so including Python and R. We have actually had a lot of issues with R. I have personally had a lot of issues with R in Jupyter. And it has to do with installing libraries. And if you have like an install, so I wouldn't recommend using Jupyter for R, honestly. And also there isn't really a straightforward way to, you have to basically change the compiler in a sense, right? Like the server, if you're working in one language in another. So if you want to combine both, then you need this kind of, libraries that basically do the translation real time, right? So I know they exist, right? Like, so I know for example, there's Python, which is C in Python, right? So you can actually call C from Python and run scripts in C from Python, right? And so there is something equivalent for R where you can from R run a script in Python and then get the results, right? But you need this kind of modules or packages that would do the translation and will be kind of running processes separately and giving provide the bridge, right? There is no really, I'm not aware of ways in which you can have interpreter doing both languages basically in the same space, right? So you will need to do it separately and then combine. Okay. So this is basically what I'd say most your everyday programming needs will be taking. Different kinds of objects and what they do and what kind of data you can store with them, what you can do with these data using methods. You can do conditionals and loops, you can repeat operations, and then you can modularize it to some extent. Now, modularization is a very kind of important concept, and it's in general, they're kind of two important, you can think of them as computational problem-solving aspects or strategies. So it's decomposition and abstraction, right? So the idea here is that if you have a complex computational problem, the first step you want to do is that you want to break it into smaller self-contained units. And then you want to kind of to solve the problem, right? In a sense, like you may have to just look at one unit and then assume what the other unit is bringing in, but without having to worry about the details, right? So you need kind of this level of abstraction where this is what functions, for example, do, is where you know what this function does, but you don't have to worry about the implementation right now of like how exactly you're going to write it, but you know that this function is going to give me the tokens, so I can already start thinking about what I'm going to do with these tokens. I'm going to count how many times they appear, right? So I can write one function without even having written the other one because I know what my function takes and I don't have to worry about what it does, right? So functions allow us to think kind of more abstractly about these sub-problems. And this, of course, allows us to modularize in these parts, and then we can solve new problems this way, right? Like, so if you have this well-defined computational task, give a text, break it into tokens, then you can apply it in all different kinds of texts, right? If a function is well written,
You can, it doesn't have to be a speech, it could be any kind of text where you can break it in tokens. And that's what these packages and modules do, right? That they don't care about your particular application. Most cases doesn't matter that much. Some cases you have to customize, of course, if you have a very specific text. So now there are two ways to do, to use decomposition in abstraction. One is with function, that's what we talked. Another way to do this is with classes. So, so there are different ways of problem solving and also kind of breaking a complex problem into separate parts. So classes are the core of what is known as object-oriented programming, which is something you might have heard. And here is also where R, so there are capabilities of do object-oriented programming in R. It's a travesty. So if you want to do object-oriented programming, it's, you know, there are other languages for that. So Python is one of those. There are also, you know, Java, there are lots of others. So the idea here is that, you know, as the name says, is that object-oriented programming, it's a paradigm, it's a way of kind of problem solving and arranging your program or designing your program that is based on the idea of objects. And object, you can think of it as a, it's kind of like, it's an abstraction, right? It's kind of like an entity that has certain attributes and it has also an interface with interacting with itself. So this is where the methods come in. So I think this will be a bit clearer. So again, going back to the question about the difference between functions and methods. So, you know, if you want to understand something, see what it is not, right? So here, it's useful to contrast often what is known as procedural programming with object-oriented programming. With functions, you can do procedural programming already. So the way it works is that you have your functions. Functions can call each other, but more importantly, the data is separate from the function, right? So you have your objects and you feed the object to, or rather object, you have your data and you feed the data to the function. And then you can feed the same data to different functions. You know, you can have different kinds of data to the same function and so on, right? But they're separate. The idea with object-oriented programming is that the data and the functions associated with them are encapsulated into an object, right? So here is, and now the functions are called methods. So that's again, going back to what I was talking about, is that now the method is attached to the data, and this method only works on this data type, right? I mean, don't think more concretely about, say, Trump speech, but think more about a speech, right? Like as a data type. So now I cannot call this method on a different class, right? Like on a different kind of object, because this is the method that only works for this type of data. And that's not necessarily the case with function. I can define a function in a way in which it can take different kinds of data and, you know, ask it to do different things. But a method is always attached to a type of data. And so a method would look, the way you define it is very similar to how a function works, but it is part of the definition of a class. Now, a class is a type of object, right? So everything in Python is an object, right? So like everything when we started talking about scalar objects and non-scalar objects, these are objects. So they are, so they basically, they have types, and they and the type is basically defined by the class, right? Like, so class is kind of a more abstract idea of object. Object is an instance of this type of object, right? Of the class. And the objects have, you know, a set of procedures that determine how you interact with them. So again, we have our strings, for example. And so if we say, if we get the type, so there is a function that gives us the type of an object. So this is the type of the string of this object S. The type of S is class string, str. That's how it's defined. And now we can, of course, call a method from this on this object, right? So we can do upper, for example, right? So we can transform this into uppercase. And so this is a method that is part of the class definition.
So this is a method you can only call on a string because it is part of the interface that Python has provided about interacting with strings. And you cannot call it on a list, right? Or you might be able to call something with the same name, but it will do something very different, right, than what it does here. So, I mean, I think this, to me, this is kind of, right, like more visually representing this, that, again, they're kind of alternative ways of problem solving. In some cases, one might be better than the other. For example, object-oriented, so thinking about your program as a kind of a combination of classes, right? So different types of objects is quite useful for kind of more elaborate software development because this allows for kind of building a software project first more distributedly. So, in a large kind of software company, right, you can have people working on different parts. And because here and it also allows for kind of updates and changing the functionality, right? Because here the idea is that everything is based on the interface, right? So the user doesn't need to know what's going on inside, and how it's implemented, but it's kind of based on you can always keep on adding new methods, for example, but the type is defined within certain limits, and so you can kind of you focus on the interface, and even if you change the implementation inside of the methods, it doesn't concern the user so much, right? And here you have to be a bit more concerned about, right? You cannot really change the representation of the data because then that will break your functions, right? This is all internal. So when you feed it text, maybe now I'm not saving my text as a string variable, maybe I'm saving it as a list, but I don't care because my methods still work, right? Like, because I only communicate with this via methods. Here it's not the case. If I'm now feeding this as a string instead of a list, then this function will break, right? So they're kind of separate. So you have to worry about this more. So this is used mainly for kind of larger projects, and a lot of the large libraries, well, programming languages such as Python, but then also most of the large packages that you will be using, such as scikit-learn and matplotlib, would be using classes in one form or another, because it just allows to build these projects more massively, right? Like in kind of incrementally, and adapt them, improve them without disrupting the users. So a very long introduction, but I mean, we don't have much time to actually go into the gory details of how you define classes. But I was hoping that, yeah, kind of wrapping it up this way, you'll be able to kind of I mean, so basically, once you understand classes, you understand everything you need to know about Python, right? Because everything in Python has been defined as a class at some point, right? So you can now go to the kind of the code for defining Python language and read it, at this level, of course, not much deeper, but and understand, right? Like how, for example, the string data type is defined, or how the list data type is defined, right? So it's basically, right, we're wrapping up, we closing the loop here. This is all these types data types we were talking about, they are a class basically, right? With methods you can use to interact, but then also there are functions. So this is also, in a sense, right, you can think of this as that, I mean, most programming languages combine both procedural and object-oriented. I mean, most programs, I should say, right? Because even in Python, there are functions such as the len function where we can feed different kinds of objects, but then also we have classes such as the string class that has methods, right? So this flexibility allows us to do lots of different things in different ways. Okay, so are there any questions? I can show you very briefly of how we are defining classes in Python. So we'll do a very kind of abstract example of, we'll define a class called person. And so the way we do it is we use this reserved word called class. Now in brackets here, so something I didn't mention, but kind of the power of also of classes is that you can have hierarchies of where you can have, one class inheriting the properties of another, but being more specific or diverging in certain ways, right? So you can have this kind of very complex hierarchies. In Python, on top of the hierarchy of classes is object. So basically string is an instance of, so it's a subclass of the object class, right? Like, so basically everything is an object, as I mentioned in Python, right? So anything, so string is defined as a subclass of object. Now we will define person, which will be at the same level as a string or a list or so on, right? That we actually, I'm not sure about this because there could be like some kind of higher hierarchies, like, you can do it as scalar versus non-scalar, but in general, right? Like, so we have a person, which is a subclass of object. So it's kind of a very basic, it doesn't inherit too much from other classes. And there are certain methods we're defining. So now we call these methods, but you can see that they look very much like functions, right? It's exactly the same way you define it. But there are some important differences. First, this one looks funny with these underscores. This one also. Then there is this argument, if you notice, parameter self, that appears quite often everywhere, right? And apart from that, I think the rest looks pretty much like just normal, right? Like just functions, right? But now they're all indented within the class definition. So now what init does, so this is a reserved way to define what happens the moment you create an instance of the class. So what we do here is that we create an object called P1 that is an instance of the class person, and we're going to create it by assigning it some attributes, right? So in this case, by definition, we have said, so what the moment you do this instantiation, you make an instance of this class, what happens is this init method is called. And what this init method requires is to give it a first name and a last name. Now, self is confusing, but this refers to the current instance of the class. So it refers to the object. So the idea here is that all of these are object-specific methods, right? So they're not kind of like class level methods. They're just specific to the object. So what this does is that when you create an instance, you have to feed it first name and last name. And on instantiation, so on the moment you create a new instance, each instance would have 3 attributes. One is first name, and this is an attribute specific to this object, right? So every object will have or most of them will have a unique first name and last name and birth date, right? On instantiation, we will bind the argument we have here so the f name will bind it to the attribute first name. The second one we give it will bind it to last name. The birth date we will instantiate with just none at the beginning. So it's not required to enter birth date when you create a new instance. Now, so this is what happens when you create an object. Now, if you want to, so let's do this. The other methods that is also special, that's the underscore double underscore string. And that's the one that determines, so again, these are reserved kind of ways of defining this. So you basically, what you're doing is you're overwriting the default init method and the default str method from the object class. So again, everything is nested. We have a subclass of the object class, and to define what happens when you create an object of type person, we have to redefine what happens on initialization and on string. You don't have to actually include this one necessarily. It will have some default behavior, but this one is often important. So, but what happens, so here we have defined that if we are to print or need a kind of representation, a string representation of our instance, of our object,
what we'll do is that we will print the first and last name together, right? So if I am now to print my object, I will comment this out. I will get, let's see, oops. I will get what I have defined here. So I will get the two names together. So these are kind of the the methods that you often need to define to just override the basic functionality. But a lot of these classes would also require certain kind of interacting with this object. So this is known as kind of get and set methods. So this often would, this defines of how am I to communicate with this object. So in this case, I have defined a few. This is not an exhaustive list, obviously, of what you can do with this. But for example, I have defined a method that allows me to get the full name. So actually, interestingly, also looks exactly the same as the string method. So in a sense, it's redundant, but doesn't have to be. I have defined the methods to set the birth date. And this is what I call here. So I have set it up for the birthday. So on instantiation, I have defined this to be 0, but now later I can actually add these information. And I have added another method of where I am actually estimating the age of that person given the year, this year, and then the year of the birth date. So very crude method. But the idea here is that I have this unique data type called person, where I can keep on making more instances of type person. So I have one, I can create many more, and I have an interface of interacting with this object, right? So I feed data, so I can each object could have certain attributes. So this would be the ones I put in instantiation or later, such as the birth date. But then I also have methods that is the only way I should be interacting with this object, where I have defined now, okay, once you have this object, how you are to communicate, what can you do to it, what kind of data can you get out of it, right? So I already mentioned the special methods, the get and set methods, and the instantiation, right? Like, so this is how we create an instance. So this is an object of type person that has these properties, these attributes. And now here, just again to kind of emphasize is that a class is the kind of the general, it's the data abstraction, right, of a type of entity, if you wish, and how we interact with it. And then the object is an instance of this class, right? So all objects have a type, or they belong to a class. Now, to go back to the example, I have basically redone, so no new changes here. Actually there are some changes, there's no way. But basically I have redone what we had before in terms of functions. Now I have decided to implement a class that I'm going to call speech. So the idea here is that instead of having these functions and then feeding them all separate data, what I'm going to do is that now I'm conceptualizing the problem differently, and I'm going to say, like, each of my speeches will be an object, and then I will have certain interface of interacting with this object. So I can start doing things to it, right? Like over it, or extract data from it, right? And so using the same kind of method definition, what I have done is that I have designed a class called speech. And when I define the class, I expect you to give me a file URL. And what we'll do is that I will, the moment you give me that, I will actually do a few manipulations to create my object. So first is that I would read the URL and extract the raw text. Then I will create another attribute called tokens. First I make them none, but because I need to read the text. But actually,
on instantiation, I would override this right away, and I will process tokens, and I would also process the word counts because I have to do the sequential steps, right? So what I'm going to do is that the moment I create an instance, my instantiation method actually calls these other ones, and my instance would have 3 attributes. It will be text, txt, tokens, and word counts. And these will be evaluated and using the methods we already, well, the functions, right? Like, so here they're methods, but in our case, right, like we wrote them before as functions, but they look exactly the same, right? The only difference is, again, this reference self. And self, yes, so what self does is that it refers to the, the attributes of the current object, right? So it's important so that it knows that it's doesn't belong to the type, but it belongs to the object itself. Sorry, I thought, like, I have an error, but it looks fine to me. So the idea is, like, anytime you have you referring to this particular instance, then you have to use self, that it's known that it's not some generic variable, but this is the attributes of this particular instance. Okay, so basically what happens is that we can have so we can create a speech, an object of type speech, using exactly what we did before, but we're going to feed it now with the Trump speech. I'm going to print, see now what happens. So by the way I have defined it is that if I'm calling the str, so which is what happens when I print, what it will give me is the first 200 characters plus an ellipse, just to show that that's not the whole thing. So if I do this, that's what it does, right? So it reads, so it does all this processing. So it creates an instance of class speech, and on instantiation, it will call this method, but then this method calls these other methods. So it has to do a bit of processing. And then I can start doing things with it. For example, I can just print it to see what it is, and I have defined how it looks like, right? I have also defined, so all of these were actually called on instantiation, but I have now also defined ways in which I can communicate with my object. So for example, I can just get simply the text that I have. So if it needs to use it in some other, I can, return the text itself. I can get the tokens. Now notice here that, for example, I'm using a copy of the tokens, and that's again, so tokens is a list. And again, to avoid this aliasing problem. So that's a good practice. There are also other ways to do it with a generator, but more advanced. But again, you have to be constantly aware, am I returning a reference to a list? Because if I am, then this might be modified in an unexpected way that none of us wants, and that's very dangerous. So anything that's a list, I would return a copy or a generator or something else where I don't return a reference to the list, as it could be modified. But basically, I have now added more functionality that allows me to interact with the object. And so I can start calling these on attributes of the object, right? So I can start accessing the attributes of the object, so the tokens, the text, the word counts, but then I can also get these other ways of interacting with it, so like, such as get the speech length, get the number of unique tokens, and so on. All right, so, and the way to call them is, of course, is that I will have to do what we've been doing is with any object and method, is that I will have to do trump get, okay, let's try this one, word count, word count. And that's what we get, right? So it returns me the whole full list of word counts, right? But that's how I've defined in my method. And again, this is my, now we call it exactly as before, but now trump is a type of object I have myself. Well, trump is an object, but it's of a type of a class that I have myself defined, right? Before it used to be, say, just a string, but now it's actually a class speech that I have decided what representation it has and how I'm interacting with it. And this is exactly what
how you're interacting with any of these packages and modules you're doing, right? That look, you have to read through the documentation to see what kind of methods or functions they allow you to do, what these methods do, what arguments they take, and yeah, similar functions like what kind of data you have to feed them, what they give you. Okay, questions? No? So yeah, so I hope I didn't lose too many of you. So I'm basically trying to fit in maybe the equivalent of 6 weeks of instruction into 4 hours. If some of you have already some knowledge of programming, I believe that it could all make sense. Hopefully there was some new insights here and some aha moments, even if it's referring to another language. For those of you who have absolutely no experience, this might have been quite a bit of confusing. But hopefully, I mean, I was able to I was trying to give you both the the more general structure of programming languages, but then also more specific ways of how we can implement this for particular tasks, the kind of tasks that most of us social scientists are facing. Okay, so in terms of next steps, so if I didn't put you off from Python for the rest of your life, and hopefully excited you about its use, I will also be happy to talk more about how it compares to R and why you should definitely learn it to get better paid jobs and more options. But there are many other resources of where you can continue your education. So there are many open courses that you can attend. I have included on the GitHub website, I have included some resources. So there's some exercises. So these are kind of a bit more contained exercise. They're free, right? You don't have to create accounts or anything like that. There are full-blown courses where you can systematically go through each of these topics in much more detail. There are things about optimization, algorithms, cool stuff, but also some of the packages that you might find useful. They're just links to sources, and there are many more resources out there. Right, and of course, if you want to take this further, my advice would be for you to write in Python at any possible opportunity. And so I know, especially if you already know another programming language, it's just very easy. Oh, I'm just going to quickly do this. I have no time to now start, but that's the best way to do it. So you have a task and you want to, and you might have to put in at the beginning the extra time to up your knowledge to be able to address this quick enough. But the more you write, the better you get at it. And it's all about practice and practice. And finally, I also, for especially those who don't have any experience with programming and just wanted to let you know that it's completely fine to look up answers online and to borrow other people's code. Of course, within giving credit and so on, but that's how programming works. There's nothing shameful about Googling solutions, as long as you have the basic knowledge to understand what it does and you really pick the right solution, right? So I think at this point we can open it for questions. We have just a few more minutes and general comments. I'll be happy to answer any of this. I would probably exit at this point so can have more face contact. Any questions? So there was a question about piping at some point in the beginning that I didn't address. So this is very interesting. So Python has so Python it's an open source project similar to R, but for whatever reason it has a much strong. Well, the reason is that it's done by computer scientists, not statisticians. It has a very strict
kind of attitude towards syntax and what is good practice and consistency and standards about naming variables and all this kind of stuff. And so piping is not something that a Python programmer, there might be some libraries that might be doing something like that, but it's not a kind of a syntax that a Python programmer would accept. Let's put it that way. There are also lots of people who don't even like list comprehensions. In general, another aspect that comes with R is functional programming. So it's a very kind of important paradigm in R of it's different. So the idea is like, you can kind of modify data in place, and the idea is that you it allows some efficiency, but actually it's not very there are capabilities for doing that in Python, but it's not encouraged in a sense. So for example, Python has like map and reduce and these kind of functions that allow for this. But overall, it's structured slightly different with a different emphasis. And again, the reason is that it's trying to be more general and probably slightly more biased towards kind of software engineering and web programming and less towards data analysis. But that doesn't prevent it from doing some of these things actually quite well and efficiently. So let that not put you away. Other questions?
So
yes,
there are a couple questions.
Yeah.
Sorry?
There's one question from YouTube. You were doing methods like process tokens and process word counts, and they are not meant to be called by the users, right? Because they're something that instantiations of the class is doing under the hood.
Yeah, so that's a great question, but yeah, this is actually quite advanced. So there are ways in which you can specify that a method is hidden and it's not supposed to be done, and but it causes a lot of kind of confusion and trouble. And so when actually teaching this more extensively, the idea is that in most cases it's not used because it might have some kind of undesired effects. So in most cases, what you could do is that you just don't have to kind of list this in the documentation, right? In a sense, and it's a lot of it's kind of interesting because right, like so I mentioned that Python is much more structured and kind of systematic and consistent than R, but actually compared to other languages such as C, for example, it has much more kind of leakage points where the syntax allows for certain problems and it's not very strict. So I know the semantics, right? So for classes, usually you don't do this kind of hidden variables, hidden methods, but you would use other methods in which to kind of make it to discourage the user from doing that, right? And it's the same with attributes, for example. Something I didn't mention is that the whole point of classes is that you want to control how users are accessing the attributes. And they have to use, that's why you have these get and set methods, because this was the interface for the attributes. However, in Python, you could directly access these attributes and nothing stops you from it unless you go through some lots of kind of hoops. And the whole point is that you just have to be very disciplined of not doing it. So there's some kind of inconsistencies that trouble some more hardcore programmers, but on the other hand might be kind of unnecessary complications for others who might be more used to R, for example. So a lot of it has to do with just kind of discipline and following the conventions. So a lot of the conventions I mentioned, for example, the use of self. The name self, it's a convention. Nothing in the syntax tells you that you cannot name it, anything you want, a bad word, whatever you want. The same with, say, global variables. That the idea to use capital letters, it's a convention. And so a lot of it relies on this, but so far it has worked pretty well. For some reason, Python programmers are sticking to the conventions much more than R programmers are, I'd say.
Yeah, thank you very much, Milena. There's a lot of thank yous and gratitude from YouTube and Zoom as well for a very enlightening session.
Thank you. And I hope you guys will collect some kind of more detailed feedback, because this was my first kind of short workshop I'm doing. So I definitely, I'm sure I have a lot to learn. So hopefully you'll get some kind of other more detailed, maybe anonymous feedback, so I know how to improve for the future. But thank you so much. And I hope that was useful to you.